Ramesh sir, I think the speaker is here.
Yes.
Whenever you say, we will begin.
Okay. Good afternoon, everybody. Welcome to the afternoon session of day one. And today's afternoon session will contain three lectures. And first session will be chaired by Dr. Indu Rao from VIT. Over to you, Professor Indu Rao.
Thank you, Ramesh sir. I feel honored to chair this session. And I also feel very honored to read the CV of our esteemed speaker, Dr. Sumit Afale. Dr. Sumit Afale, I think his video is not on. Shall we request him to turn on his video?
Yes, ma'am. There is a display slide from our side. So once we are done, he will start.
Then he'll do that. So Professor Sumit, welcome to VIT and welcome to this session. For the audience, Professor Sumit is at University of Aberdeen, UK. He has obtained his engineering from Pune, so he has a background which is international. He did his BTech from India, and then he did MS and PhD from United States, and after that he is working in the UK, United Kingdom. So we are honored to have him with us. Not just that, he is a great academician. His research speaks for itself. As you can see, 75 plus publications in international peer-reviewed journals and conferences, 1500 plus citations, H-index 13, I-10 index 20. He has got research funding of huge orders as seen in the PPT. He is editor of prestigious journals and he has guided several PhD students. I welcome you, sir. Professor Sumit Afale, over to you.
Thank you for giving me this opportunity. It's weird times that we're in, but there's a great opportunity to link up. Hoping that my audio and video is okay. I'm going to start the presentation. I'll just share my screen, just confirm that you can see what I'm doing here. Let's see. And it doesn't show me. Yeah, okay.
Audio is fine. So.
Yeah, audio is fine, but I'm just seeing why I don't see the video because I'm sharing the video and for some reason okay, yeah, maybe here, yeah, okay. Right. Because I've done this several times, but for some reason, yeah, now.
Yes.
Okay, let me know. Yeah, let me know if you can see something.
Yes.
Right, okay, so this is the talk I'll be giving. The title is Recent Developments in Control of Nanopositioning Systems. I've sort of structured it for a more general audience, seeing as this is a multidisciplinary conference. So I tried to keep the detailed, technical equations and stuff to a minimum. So let's see how it goes. I'll start by introducing the topic of nanopositioning systems, what they are, how we construct them, why they are required, and so on. I'll then move on to the problems associated with nanopositioning in general, discuss basic mechanisms that kind of limit how best we can position something at the nanometer scale. I'll go through an overview of remedies. I've been working in this area for about 15 odd years. Probably seen most of the remedies that there are out there. I'll briefly snapshot a very recent experiment of ours, which I think pushes the boundaries of what nanopositioners can do. And finally end with a future scope of where I think this is heading. The aim of the talk is hopefully I'll enthuse many of you, or at least some of you, into collaborating with me, be it staff members or students. So that's where we are. Right. So if stuff starts working. So this is sort of the what, where, and how of nanopositioning, really. Nanopositioning, as the term says, it's positioning matter at a nanometer scale. And nanometers is 10 raised to minus 9 meters, which is quite tiny. We don't immediately see how tiny it is, or cannot gauge how tiny it is in a sense. So here is a sort of thing to scale us. Forget the watermelon, because watermelons typically are bigger than 10 centimeters. But if you follow that, then a human hair has about 100 micrometers thickness. And we think that that is quite thin anyways. A typical virus is about 1 micrometer, and the nanometer then is 100th of that 1 micrometer. So we're talking of very small things. When we look at literature in nano positioning and so on, you'll see that people are really moving in the micrometers, but for some reason it's called nano positioning. And the reason is mainly because of the resolution. So how minutely, how accurately can you move that kind of, sort of dictates what the terminology is. And even though your overall motion range is in the micrometers, the resolution that you're looking for is nanometers, so that you can then look at details of a red blood cell, for example. What are the applications? Nano positioning kind of started in the 1950s, late 1950s. And the person who invented a technology for positioning matter at nanometers actually won a Nobel Prize. Is a scientist from Switzerland named Binning. And one of the main primary applications was microscopy. We sort of think of microscopy as seeing things under a lens, but there are other ways of looking at things. And one of the easier, more intuitive ways of finding out about things is touching them, right? We sort of touch and we can find what the roughness is or the smoothness is, whether it is wet or dry and so on. And so nano positioning then enabled something known as atomic force microscopy or scanning probe microscopy, where rather than looking at matter through a lens, we actually touch matter and find out what the topographical map of a particular sample is. So here is what an atomic force microscope sort of looks like. A very simple system, but it enables us to interrogate matter at the nanometer scale. So we have a piezo scanner, which is basically our nano positioner. It sort of positions whatever we place on it, the sample, in nanometers. And then we can move the piezo scanner around the way we want it in X, Y, and Z axis. And that sort of moves the sample around. We have a probe, which is also known as micro cantilever in many cases. And as the sample roughness changes, or the topographical map of the sample changes, the probe or the micro cantilever deforms or deflects. That deflection is sort of recognized by this reflected laser beam, which is then projected onto a photodetector. And then we have signal processing algorithms, which will tell us what the map of that sample is. Here is a small video of how this works. So probe going through a sample, finds a feature on the sample, and that feature gets recorded as a topographical map. So what you see on the sample is what you sort of get as a map at the end. It's a very, very simple device, but gets used in a lot of material science interrogations, or cell biology, or stem cell research, and so on. The next application, which is sort of very in vogue right now, is MEMS and NEMS, which is micro nano electromechanical systems. The whole area was started by Richard Feynman, I think, in his very celebrated lecture in about 1969, which said there is plenty of room at the bottom. And the idea is that we are always looking at macroscopic levels, large masses and springs and dampers and so on. But as you look at these things, you need more energy to move them. You have friction and stiction problems. You have other large dynamic problems that sort of get simplified if you go to a smaller scale. So we're talking about either crystal scale or micro, molecular scale and so on. Obviously, there are problems associated with those scales as well, but the energy required to resolve those problems is significantly less. Here is a MEMS-based accelerometer, in a sense. we know how an accelerometer works really, right? Mass times acceleration is force. So in a sense, when acceleration is sort of experienced by a mass, it generates some sort of a force. That force then gets resolved into either a voltage signal, which is proportional to the acceleration and so on. Here is a MEMS-based accelerometer. And so this scale is about 2 microns. So it's 2 microns that way, it's about 4 microns that way. Right? So it's a very small piece of equipment. And what is happening is when this chip, in a sense, experiences acceleration, the mass sort of moves in the direction shown. These plates are, initially at a fixed location. You can measure the capacitances between the fixed plates and the moving plates. You can do that at each of these series of plates. And then as the distance between the fixed and the moving plate changes, the capacitance in between them changes. And that then gets resolved into acceleration measurement. Very easy to use. And nowadays, actually very cheap. You can get a MEMS-based accelerometer for probably £10. And then there are other applications. How do you make these MEMS-based devices? You actually have to etch out material from a surface. You could use them in semiconductor industry and so on. And if you want to etch these things accurately, then you need something that moves accurately at those scales. So again, nanopositioning. So in a sense, nanopositioning is a key enabling technology in a wide range of engineering or technological applications. One of the things that sort of interested me at the beginning is this high density data storage. We know what a hard disk is, and we know how the capacity of the hard disk has changed over the years. Well, IBM really pioneered high density data storage. If you open up a hard disk right now, then you have a disk which rotates at a particular RPM, and then you have one needle. And that needle, basically, like a probe, it writes data at different sectors. A high density data storage device is the same disk, but more finely sectored. And instead of having one needle, you may have 100 needles. So you're sort of writing data in a dense fashion and in a fast fashion. A couple of my colleagues at IBM, Abu Sebastian and Giovanni Cherubini, actually pioneered that system overall. And then how do we enable nanopositioning? The most popular way is sort of piezoelectric actuation and capacitive sensing. This is how it works. So if you want to move anything, you need two things. You need something that delivers force. It could be a motor or your hand that pushes something. And then you need to sense how much you moved. So you need an actuation mechanism and a sensing mechanism. You can look up literature and there'll be nanopositioners based on magnetic levitation. There have been nanopositioners based on lead screws, which is basically the same screw that you use in your screw gauge. Stepper motor based nanopositioners. The most popular nanopositioners currently available or currently being researched are those which are sort of actuated by piezoelectric crystals or stacks. Piezoelectricity is a very simple phenomena. You apply force, it gives you voltage. You reverse that and you give it voltage and it deforms or gives you force. And you use that force to sort of move at the nanometer scales. It's a really nice, simple mechanism. And then piezoelectric crystals don't have friction or stiction because there is no real, gear mechanisms or anything. They're highly repeatable, so you get consistency in your motion. And the resolution is limited only by their crystalline structure in a sense. So you could actually go up to molecular levels, so easy nanopositioning. And they have a very high force component. So in one axis, so when you're looking at just elongation or compression, they have huge force capabilities. They don't do very well with twisting because piezos are ceramics. It's the same stuff that is similar stuff that your bone is made of, or what your cups and saucers are made of. So they really have very high force in one axis, but they have very low force capability in the twisting axis. And then the sensing could be done either by a laser triangulation. Note that we are looking at measuring distances which are 1 nanometer or less, right? So a laser triangulation sensor can be used. People have used strain gauges, which is another piezoelectric patch. You can can kind of paste on your positioning axis, and then the strain experienced by that patch will be resolved into a displacement. Capacitive sensors are sort of the most popular one because they're robust, they're easy to use, and they're easy to sort of plug and play. So here is what a nanopositioner looks like. And the construction is really simple. A block of aluminum. So this is something that a colleague of mine from University of Nevada designed and built and sent it over to me. So we use this in our experiments throughout. It's a 2-axis nanopositioner. Those small yellowish brown whatever thingies are piezoelectric stacks. So if you trace the way force is sort of generated and delivered, then that stack is fixed at that end, so it can kind of expand or contract along that end. Here is a motion amplifier lever. So force gets experienced at that direction. If you follow that path along, then that is where it connects to the main platform. That platform is connected to the main body by leaf springs, or what we call flexures. They're exactly like your car springs. So they minimize friction and stiction and give it some sort of a control, a rigidity. And then it moves that entire platform in that direction. The same thing happens on that one. So that part is fixed, that part elongates or contracts, follow that motion through, and then it moves the platform in the other direction. So we have an X and Y sort of positioning platform, very simple. Those two pieces of cylinders that you see, they are basically the capacitive sensors. So we have a polished surface on that end. We have another polished face at the capacitive sensor, and the air gap in between changes as this platform is moved in each of the axes. The change in air gap equals change in capacitance that then gets resolved into motion. If you buy this setup off the shelf, it'll probably set you back by about 50K. We made this in-house for about 3.5K. So, you know, it's a really simple device, but once you start adding on the company logo, the price sort of goes up. And here's how it works. So piezoelectric stacks, and it's sort of moving in X and Y direction, right? And then there are flexure springs. So flexure springs would sort of allow it to be in position. These are really robust devices. I've seen devices that can move up to 200 microns. And that may not be a huge amount in our generic scale, but think of nano positioning, then we are moving several orders of magnitude. So we are looking at a really large range of motion in a sense. Right. So then we sort of look at problems. So if everything is so nice, you know, we have a simple device, we know how to sense it, the sensors are accurate, the device is simple, easily controllable, repeatable, stiction and friction free. So what are the problems associated? And really nano positioning is not as easy, otherwise I'll be out of a job, right? So nano positioning basically has 3 key problems. One of them is the mechanical resonance. That's the linear dynamics of the system. Every system that has mass, I mean, this nanopositioner was made of kind of metals and piezoceramics or whatever. Then you have a simple mass spring damper system, and then complicated connections of various masses and springs and dampers. And then we know root K over M, spring constant over mass, is a resonance. So we have resonance. I'll show what this resonance really does to us. Hysteresis is basically the nonlinear behavior of the piezo actuator, which is saying if you ask the actuator to go through a cycle of expansion and contraction, then it doesn't really do it in a linear way. It doesn't follow the same path. It's exactly like the hysteresis you see in a magnetic BH curve. So you energize a magnet, it follows a particular curve, a particular path, and when you de-energize it, it goes to another path, right? And the third problem is creep, which is saying if you energize the piezo and leave it energized, then it sort of slowly changes its deformation or length. So over a period of time, you get a creeping sort of behavior. Now, what we want to do with nanopositioners generally is we give it a trajectory. It may be the path that we want to etch if it's nanolithography, or it's a scanning pattern that we want to follow when we are scanning a sample and so on. And we expect that the nanopositioner is going to accurately follow the same scan pattern. Scan patterns have sort of evolved over the years, but the popular scan pattern is something that was designed for black and white televisions, which is a raster, right? Which is a triangle wave on one axis, a slow ramp or a step on the other axis. A triangle wave, everybody knows, is made up of infinite odd harmonics of the fundamental. So you have a lot of frequencies associated with it. As soon as it interacts with the resonant system, this is what happens. So here is the frequency response of a resonant system. So that's frequency, that's magnitude. At some frequencies, the input to output amplitude, the gain factor is 1. But as soon as it starts reaching resonance, that gain changes. And sometimes this gain could be 20 or 40 times what the input is. A triangle wave in frequency domain is reducing amplitude by the factor of the square for all the fundamental odd harmonics. That frequency signal interacts with the resonance. What you get in the frequency domain is some frequencies sort of get amplified. If you look at that in the time domain, what you want is for the triangle, for the nanopositioner to just go up and down over time. And instead, it experiences this high frequency jitter because some frequency components of the triangle wave have been magnified or amplified by this resonance. Now, one thing is it gives you really poor imaging, but the other important bit is everything that shakes at some time will go through fatigue and will break. Piezo's are ceramics. If you sort of vibrate them at high frequencies and at high amplitudes, then their operational life is significantly reduced. When I started working on these systems way back when I was a postdoc, my second experiment resulted in cracking of a nanopositioning tube. The tube is cheap, 200 pounds, but sourcing it from another country and then shaping it and etching it for the right electrodes, it set us back by about a good eight weeks. So being aware of resonance of any system, definitely for systems as brittle as piezo actuators, is really useful. Hysteresis is just there. So again, all I'm doing is trying to move the nanopositioner just up and down in a raster pattern over time. And because of hysteresis, the trajectory that the nanopositioner takes moving up is not the same as what it takes moving down. So if I plot input versus output, in the ideal case, I would have wanted a straight line. Instead, what I'm getting is this weird hysteretic curve. Right? And depending on how large the piezo stack is and how well I've designed the flexures of the positioner, this loop can go either broader or thinner. And then the third bit is creep, which is I energize the nanopositioner and then kind of leave it for some time. Then ideally I expect a constant position, the expansion of this piezo to be constant. But as you can see, very slight, but we're talking about nanometers here, right? And that is a significant problem in a sense. So this is microns, and within 100 seconds, this has almost gone 1 micron, right? This is kind of moved or creeped by a micron, which is 100 nanometers, 1,000 nanometers in a sense. So what's the end result? Here is the end result. If you wanted to scan something, so here is the overall effect in the sort of time to frequency domain. Here is what we want it to do, just go up and down. It interacts with the linear resonance part and the piezoelectric nonlinearity and creep. And what we end out as an actual displacement is high frequency components, deviation from linear, as well as this creeping. Here is an actual experiment that we did about 4 or 5 years ago. So this is a standard grating. You could think of this as a PN junction, a series of diodes in a sense. So we have a P wafer at the bottom, we have an N sort of wafer which has been etched out to make a series of diodes, a PN junction. And they're really nice. So they're perfectly square or cubes in a sense of 2 microns each. But when I scan them to see whether they have really been etched properly, you can see that those wavy lines are because of the resonance. That line, the curvature of that line at the bottom does not match with the curvature at the top. That's because of hysteresis. And the entire scan sort of is skewed, so it's sort of slanted in one direction. And that's because of creep. So all those 3 things together give you a really crappy scan of what is a very well machined or well etched sort of device. So what's the point of using this high error device to quantify how your machining has happened? And that's the reason why so if you wanted to machine this or nanolithography, you would still need a nice device. Once you machined it, you need something which will test that you machined it correctly, which is another nanopositioner, and we would still need to get rid of these problems. So that is sort of the motivation for why we need control. So you can design the best possible nanopositioner, but you will never be able to get rid of these fundamental physics-based or material-based flaws. You will always have resonance at some point. You will always have hysteresis as long as you use piezoelectric actuation, and you will always have creep. Some of the effects you can sort of get rid of. So creep, for example, we know only affects it if we are looking at long time scans. So if you have a sample which is dead, inanimate objects, like silicon wafer, for example, and if you could really scan very fast as in the frequency of this up-down motion was in the thousands of hertz, you could very well get rid of creep because there isn't enough time for the positioner to actually creep up. But if you wanted to scan at very high frequencies, then you will have a triangle wave which will have higher frequency components, which interacts with the resonance, right? So if you wanted the resonance to move away, root K over M, you either had to reduce the mass or increase the stiffness to increase the resonant frequency. The way you could reduce the mass is by shrinking the entire structure. But you shrink the entire structure and you lose the overall motion range. So there is this cyclic argument, right? You can't really deliver everything that you want in open loop nanopositioner design. You can't tick all the boxes just in the design stage. And that's the motivation for our control. Let's see if I can. So then we're looking at remedies. And the remedy is control. So one remedy is the mechanical design. We can improve some of it, but then, at some point you'll still need control. And the motivation is this: it would be ideal if our nanopositioners have absolutely no detrimental effects. We can't have that. Well, then it would be best to have no detrimental effects show up at the output. So show up at the displacement of the nanopositioner, which means if I ask it to move from point A to point B in a straight line, then it follows the exact straight line. Now, we could do that if I have infinite amount of time. We don't have infinite amount of time. So I want to go from point A to point B faster, right? Which is a different problem. Then I want to go from point A to point B and end as close as possible to point B, which is another problem. Then I want to follow this track between point A and point B as accurately as possible, which is another problem. So every time you sort of add on to your desirables, you're sort of making the control problem more and more complicated, right? But there are 3 things that we want, very, very straight off. We want to sort of damp the resonances. We want to somehow get rid of hysteresis and creep. And what I mean by get rid of is get rid of the effects of hysteresis and creep at the displacement side. And we know that a nanopositioner typically is used for scanning samples or moving samples, which means stuff is going to be put on and taken off. And stuff has mass, which means, again, root K over M, your resonance frequency would change or your K would change. So it needs to have some robustness in terms of parameter uncertainty, right? So that finally we get high scan rates. How high do we want them? We ideally want video rate. Video rate is probably 60 frames per second. If you think of one frame, then think of how many lines you need per frame. That's based on your resolution. So let's say you wanted a scan of 100 microns by 100 microns with resolution of 1 nanometer, then you're looking at 100,000 lines. You want to do 100,000 lines, and then you want to do 60 of those scans in 1 second to get video rate. We're nowhere close to that, right? The fastest I've seen is about 50 lines. 50 lines really does not give you too much. Right? So control, as always, two different possibilities: open loop control and closed loop. And based on the name itself, it's obvious what we are trying to do. So open loop control, oops. The main pro is it's cheap because it does not need a sensor. It does not have a feedback. So the output is not fed back into the system for correction. So we don't have any stability issues, nothing, right? The problem obviously is the performance is typically poor. We have no robustness because every time something changes, like the sample, then something from the input side has to change. So every time we need to tune the input to make sure that the output sort of behaves the way we want. And that's why it's least popular, because it does not give us the right picture. But there have been research studies that have come across some solutions. I mean, if you wanted a cheap solution for a really coarse nanopositioner, one of the solutions is a notch filter.
Yeah. Professor Sumit, it's just a reminder, you have 10 more minutes and 5 minutes we have for the question answers.
Yeah. So a notch filter is basically inversion of dynamics. You have a resonance, you just invert the dynamics and then think that, well, everything is okay. Inversion doesn't really work because pole zero cancellation in real time does not work. You could do a hysteresis inversion, which is the nonlinear bit. So you have your linear dynamics, which is a transfer function. You have a hysteresis curve, and you invert that. And that doesn't work as well because hysteresis is rate dependent. So the frequency of the input changes, the hysteresis model changes. And then you have the full dynamic inversion, which is sort of saying, let's take the entire dynamics, the linear and the hysteresis, and invert that. But again, the same problem. The dynamics for the linear side is dependent on what the sample is, because the mass adds or subtracts. Then every time you need to change the inverse. So it doesn't work there as well. Closed loop kind of does really good stuff. It's more accurate, it's robust, but it has problems with sensing and stability and so on. The traditional approach has typically been twofold, which is saying, here's our system. We use a damping controller to damp the system resonance, then use a tracking controller to sort of get rid of these issues with hysteresis and creep. And damping, as we all know, I mean, if you look at the pole zeros transfer function sort of language, then as the pole moves away from j omega axis, you damp the resonance out. So you need some sort of a damping controller. Lots of damping controllers exist, and I've been lucky enough to work with almost all of them. But what you can note is, if you look at the exponent here, s squared, that's an integer. 2 is an integer, right? So we thought, well, why not go a bit further? And then I'll discuss that in a minute. Then tracking, the simplest tracking controller, PID or PI would work, because all we're trying to do is force the output to just track the input. So ultimately, our control strategy would be one of the various damping controllers there, a tracking controller there. You damp the system first, then you track the system. That was the standard intelligence. We found out that if we do that, so here is the original pole, very close to j omega, so very lowly damped. Push the poles apart, and then use a tracking controller, increase the gain of the tracking controller, the damping really changes. So we came up with an idea that we'll do this simultaneously. and we could see a significant increase in tracking bandwidth. So we've sort of proved that simultaneous design is better than independent individual design or sequential design. But the recent advances have basically been here. So let's look at nonlinear control, so sliding mode control or repetitive control. What we've been interested in is fractional order control. So here is a very recent experimental result. Here's our experimental setup: nanopositioner, amplifiers to energize the piezo's, capacitive sensor, linear dynamics only looked at, because we're going to enforce tracking using a PID or a PI. Comparisons of control methods in closed loop. But here is the interesting bit. So this is the sequential design, a damping controller and tracking controller. If you look at the order of the denominator for damping, it's 2, tracking is 1. Simultaneous or butterworth design is the same, 2 and 1. And we said, well, why not just optimally distribute just the orders, not change the controller parameters, just distribute the orders. So we want an addition of 3. And here what we've done is damping controller 2.1, tracking controller 0.9, fractional order systems. And we have gotten significant improvements. Note that this is nano-positioning. Errors are given in micrometers. So we're looking at a few tenths of nanometers improvement in accuracy, which is nice. This will go out, come out very soon in IEEE transactions of mechatronics. And then finally, where is all this going? Here. Because computers, softwares, mechanisms getting better, we sort of have a sort of direction to go. FPGAs are getting mainstream, so rather than using lab view sort of systems, we are using FPGAs now. The mechanical designs are improving. I have a colleague who has recently designed a nanopositioner as a MEMS nanopositioner. So it's a wafer on a wafer in a sense. We've only scratched the surface of fractional order control, which is, that exponent being a fraction. But we are looking at even complex order control, which is like S raised to A plus JB, where we can sort of tune in magnitude as well as phase automatically. And we've recently received a grant on internal modal principle-based control. Don't know what that means really, but I'm studying, right? So that's where it is. And I'll be happy to talk to people if they have ideas about any of this, if they have projects or they want to be involved in any of the projects here, or if there is another control strategy out there that you think is useful. Obviously, I've not talked about any of the adaptive control or repetitive control or genetic algorithm-based control or sliding mode control, because we want to keep control simple. Simple control gets implemented. So one of these control strategies actually is now being patented. And if you tell people that I'm going to design this fancy sliding mode controller for solving this problem, you'll get nowhere except for a paper. But if you want the control to be implemented commercially, then you need it to be simple, easy to design, and robust. So that's where it is. That ends my talk. I'm happy to take questions.
Thank you so much, Sumit, for a wonderful. This is a transdisciplinary conference, and you shared your knowledge about the nano positioning systems. Excellent presentation. Thank you. There are a few questions. May I read them to you?
Yeah, please.
Yeah, one of our faculty has asked that you mentioned 50K market price and lab-based developed system was 3.5K.
Yeah.
So what costs are in UK pounds?
Yes.
Okay. So I think that is the answer. If you have anything else to speak on this. Okay, so the other question, I think that he has clarified that it is in UK pounds. The other question is, what is the smaller structure you can scan in this way?
What is the smallest structure I have seen scanned in this way? I have myself scanned a red blood cell. I'm sure that there are people who have gone on to look at even mitochondria, so significantly smaller. I mean, if we're talking about a resolution of 1 nanometer, then think of everything that falls within that resolution. And you should be able to scan it as long as it doesn't get destroyed by the probe actually probing through it, because we are actually touching that. So some biological samples really would be destroyed, right? But I mean, there are ways to avoid that. You have, instead of the fixed sort of scratching scanning, you have tapping mode. Atomic force microscopes have now changed. They even have this electron conduction mode. So there are ways around it. But as long as you can withstand any of these interrogation methods and you are okay with a resolution of 1 nanometer, you should be able to scan that.
What kind of vibration isolation system you use?
We don't want to use it. I mean, would you use a vibration isolation system for a microscope, an optical microscope? And the answer is no, right? I mean, when computers started, we had to take off our shoes. We had to go in a clean room with an AC. Nowadays, the computer is in our bag. So it's the same kind of concept. If we make this non-accessible to people, then it's not going to be a technology that is widely used. When we started off, there was a vibration isolation table. Thomson provides one. But what we realized is that is not going to make it accessible, because many times the vibration isolation table and the associated circuitry is larger and more expensive than the nanopositioning platform or the atomic microscope itself. So we don't use anything. We just use a solid base. So the base is heavy. I mean, that small nanopositioner is about 7 kilos, right? And 7 kilos of aluminum, so it's really thick in a sense. But no, we don't use vibration isolation tables. I've not seen too many people use vibration isolation tables, because then that just kills the application.
Okay, so Ramesh, so you had your answer. The next question is piezo nano positioners. What is the lifetime of this piezo nano positioners?
So if used well, I have been using the same nano positioner for the last 11 years. So the lifetime basically depends on, and I mean, clearly I've been using it sparingly, let's say, but I'm involved in a company, with a company which does nanopositioning systems in a sense. A piezo crystal has a life cycle of a few 100 million cycles, right? So that's the amount of time it can go up and down. The mechanical system probably have less life than that. The flexures really have lesser life than that. But, I mean, I've been using it for more than a decade. I've done hundreds of experiments on it. I've written quite a few papers on it. Many of my controllers initially are unstable, so they're already beyond the safety limit of the nanopositioner, and still I have managed to keep it intact, so it should be okay. It's a robust system.
Thank you. So what is the highest accuracy in positioning achieved till now after taking into account all the parameters mentioned by you?
A nanometer.
What did you say?
1 nanometer.
Okay.
If we couldn't do that, then we would not term it nanopositioning, right? So you could easily see people. There is a group in Japan headed by Professor Toshio Ando, which is sort of the pioneer in biological high-speed sample scanning, and we could do 1 nanometer. I have heard, I have never seen it, but I've heard of people who have done something less than nanometers, or smaller than nanometers. So I don't know, maybe picometers, but I have not seen it.
But your RMS value is still pretty high, about 20 nanometers.
That's right. So this is because it's
STMs, and please let me finish the question. We already have STMs and AFMs with atomic scale resolution. So,
yeah.
So your RMS value is still pretty high, about 20 nanometers.
Yep, absolutely. And the reason for that is my mechanical system has its own limitations. So the system that I'm working with has the first resonance at about 700 hertz. If you go to a system which is having a resonance of about 20 kilohertz, then you could get to a nanometer. There is also a difference between what is being claimed and what it really is. So for example, the results that we show here already have the sensor noise and the process noise included. Whereas when you look at systems, commercial systems that tout a nanometer resolution, then they have post-processing that kind of gets rid of or filters out the sensor noise or RMS noise. I mean, if you look at a simple high voltage amplifier, then to get 1 volt, one nanovolt per volt in noise is difficult. So if somebody says, well, I can do 1 nanometer positioning, definitely there is going to be some sort of post-processing of data. And it's not raw data. What we are showing is raw data.
I have a feeling your session was very interesting because we had so many questions, so many people could relate to what you were talking. We have 5 more minutes, so may I ask a last question from you? If you have to just translate this is a really technical session. We are all engineers, so we can relate to it. But if you have to translate the importance of this session to just to society, to somebody who can use it, but would not understand so many technical things, how would you do that?
Would you not want to see how the COVID-19 looks like to be able to find a way to kill it or eliminate it? Here is a way. I
Okay,
think this is probably the most relevant answer I can give under the current times.
Interesting. So just elaborate a little more. Because we have 4 more minutes. I'm sure you can do that.
So a virus basically is a protein, right? And unless we know the exact protein structure, we don't really know what can react with this protein structure and eliminate it. I mean, I'm currently working on a project which tries to burn the virus using a laser, right? But that is sort of, energy intensive. But if you're thinking of medical diagnostics sort of research, then you would want to know what the protein structure is. And if you want to see what the protein structure is, you could use an atomic force microscope, and that will help you design another protein, a counter protein in a sense, that will react with this and sort of eliminate that.
Thank you so much. Post-lunch session, and our participants have had a very nice time. They have appreciated your session. It was nice, very informative. Thank you so much, sir, for joining us. Thank you for sparing your valuable time and talking to all of us for this and contributing to our conference.
Yeah, thank you. It was fantastic. And if you have more questions or people who want to collaborate, please send me an email.
Sure. So Ramesh, sir, would you like to conclude? Or
Yes, I can do that. Yes. So thank you so much, Dr. Sumit Pale. It was wonderful talk. Being the first session in the afternoon, it was quite interesting. I also, on behalf of our Department of Physics and VIT University, I thank you again for accepting our invitation. On behalf of, again, the organizing committee, I thank Professor Indu Rao for sharing this session. Thank you so much.
My pleasure.
Yep, thank you.
Yes.
Good day.
Good day.
Thank you so much.
Dear participants, we still have 10 more minutes for starting the new session. Please wait. We will start the new session pretty soon.
So wonderful. I have a nice break. And thank you. It was very nice to be with you, Rajan sir, Ramesh sir. Excellent.
Yes, sure.
And hello to the next speakers. And I hope you continue to have nice sessions during the afternoon.
Yeah.
Thank you, madam. Whenever you are free, please join with us.
Yes, definitely. Yeah. Sure.
Thank you. Thank you.
Bye-bye. Bye.
Professor Giuseppe, 10 minutes more. Let us wait for. If you want, you can share the screen, the first slide.
Yeah, I will do. Can you see the screen?
Hello. Yes, we can see the slides. Yeah.
Okay, perfect.
Yeah. Yes.
Prof. Ramesh, chair has come already.
Okay. Okay. Fine.
Yeah, he has joined.
Okay.
Hello, good afternoon. I'm here, and we can start session.
You can switch on your video, please.
Yes. Hello. Very good afternoon to all, Professor Giuseppe and Professor Rajan Babu and Professor Ramesh. And it's a pleasure meeting you, Professor Giuseppe. We have been communicating through emails regarding our MOU and cooperation. And it's a real pleasure to meet you over virtual conference. I'm much happy to chair this session. I'd like to thank the Dean, SAS, Professor Mary Sarel, and also Professor Rajan Babu and other colleagues of VIT for providing me an excellent opportunity to chair this. We'll start this session as early as possible. And yeah, please let me know when we should start the session.
Professor Srinivasan,
Yes.
we have scheduled this at 15:30, so we'll just wait 5 more minutes.
Shall we wait?
Yes.
Yes, sir. Better shall we can wait for 5 more minutes.
Yes.
Oh,
Professor Srinivasan,
Yes.
can
Shall
we
we
start?
start?
Can we start?
Yeah. Yeah, that's fine.
Yeah.
So,
let me just introduce once.
yeah.
Good afternoon, everybody. Welcome to the second talk of today's afternoon. And we are happy to tell you that this session will be chaired by Professor R. Srinivasan. He is the Deputy Director of International Relations Office, VIT Vellore. So over to you, Professor Srinivasan.
Thank you, Professor Ramesh. It's very good afternoon to everyone, and to Professor Giuseppe Maruccio from the University of Salento, Italy, and Professor Rajan Babu and Dean SAS and other faculty members from SAS and VIT. So it's my pleasure to chair this session, and I would like to introduce Professor Giuseppe before this session. And he is a full professor of physics of matter at the Department of Mathematics and Physics at the University of Salento, Italy. And he is the very active collaborator with the various countries and also with VIT. And Giuseppe graduated in physics at Leeds University from its institution in 1967 in 2000, and also got his PhD in 2004. In 2005, he worked in Hamburg on mapping wave function mapping of spatially resolved DV images. In 2010, he was the chair of the international conference, and also with the participation of Professor Al Bedford, the father of spintronics and the Nobel Prize in Physics in 2007, and also guest editor of Conference of the Proceedings. And Professor Giuseppe is author of more than 130 publications and 4 patents, in addition to several invited contributions at the international conference. And he is very active in the field of research, and also published books, and also authored some of the book chapters. In 2016, he was awarded the Excellence Award in City of Leeds in 2017, and he was part of working group, and he is having close contact with the many international universities, and also brought projects, funded projects. And once again, I would like to welcome Professor Giuseppe to deliver his talk, and hope our audience will enjoy this session. And after this session, after his presentation, we will have a 10 minutes question answer. You can, you are welcome to ask your questions and clarifications. So let us learn together. Professor Giuseppe, over to you.
Thank you, Professor Signorasan, for the introduction. And I want to thank the organizer and in particular Professor Rajan Babu for the invitation to be a speaker at this conference. I think you should see my desktop with the slides.
Yes.
So, okay, perfect. So the topic of my talk concerns cavity magnonics with Higgs sphere systems. And here you can see a brief outline of the talk. We'll first discuss about spintronics in terms of achievements and trends. Then I will switch to magnonics and cavity magnonics in particular, and at the end I will give some perspectives and maybe if there is time also some slides about a few other activities we are running in Lecce. So what is Lecce and what is my lab? So I came from Italy, I am in Italy, and Lecce is just here in the southeast, just in front of Albania and close to Greece. And so it is a beautiful place with sea and heart. So if you get the chance to visit us, we had Professor Rajan Babu here 10 years ago for the conference I organized at TSN 2010, where we meet the first time. Concerning the laboratory, a few words before talking about science and results. So in my group, I have two main laboratories and activities. One is the spintronic lab, and here you can see some of the largest equipment. We have a cryogenic superconducting magnet and an Oxford dilution fridge, so we can go down to 10 millikelvin. We have a vector magnet, and we have in terms of magnetic field, we can go up to 10.5 Tesla. And then we have also a cryogenic RF probe station to we can perform measurements up to 70 gigahertz. So this laboratory became recently the Italian node of the European Infrastructure on Magnetism, which was founded within the Isabel project, and it will just start the project in this month. The second activity concerns lab-on-chip and biosensors. And here you can see the laboratory, some of the devices we fabricate. And maybe at the end of the talk, if there is still a few minutes, I will show a couple of slides about these activities. In our facility, we have also a clean room where we fabricate all the devices. So micro and nano fabrication, deposition, etching, and so on. Concerning spintronics, spintronics attracted a lot of interest for several applications. First, the first one is, of course, magnetoresistance to be used for readout of data in hard drives, but also magnetism is used to store the data in these drives. Then other applications concern sensors and biosensors, more recently spin qubits and quantum computations. And there was a lot of interest also in the last decade about oxide spintronics and the new materials such as showing multiferroic properties, so with having both, for example, ferroelectric and ferromagnetic or antiferromagnetic properties, and with magnetoelectric coupling. And then also in terms of miniaturization, worldwide, there is a strong activity toward nano spintronics and molecular spintronics. In particular, it is very interesting to use single molecule magnets for fabricating nano devices or also quantum devices. So for sure, magnetic multilayers and metal spintronics is the starting point of the field with the work from Albert Fert and Peter Grunberg that was awarded by the Nobel Prize in Physics in 2007. But also, for example, in the group of Professor Wiesendanger and a few other groups, but in the group of Professor Wiesendanger, where I was a postdoc, it was developed the spin polarized STM that allow to have magnetic information with atomic resolution. These are single atoms, and you can see the contrast depends on the magnetic moment of the single atom. So I have no time to go into details, but then, of course, if someone is interested, we can then speak in more detail. Still, as a recent trend of magnetic multilayers, there is the possibility to use spin torque to produce spin torque oscillators working in the radio frequency range, and also sensors and biosensors, where, for example, the analyte is detected once labeled with magnetic nanoparticles, and the stray field of these magnetic nanoparticles give a response, a change in the response on the magnetoresistive device. In terms of semiconductor and oxide spintronics, the interest was strong from the early of this century in combining semiconductors and spintronics, for example, injecting spin polarized carriers, or having some magnetic doping in order to have a controllable ferromagnetism, for example, controllable by means of a gate electrode within these kind of materials. And also, it is possible to encode the information at the quantum level in quantum dots, and such as in this work from PETA, and to implement some quantum algorithm where the information is stored at the quantum level in the spin of single electrons trapped in quantum dots or double quantum dots. And more recently, topological insulators attracted also large interest, along with multiferrotic materials, where, for example, it is possible to control the magnetic properties by means of an electric field, which can be more easily miniaturized for in devices. In terms of molecular and nanospintronics, in these slides I'm showing some results from literature about the use of magnetic nanoparticles in miniaturized devices at the nanoscale, or single molecule magnets where you can see the quantum tunneling of magnetization as steps in the hysteresis loop. And here the information can be stored again at the quantum level. Or Kondo effect and single atom, so-called single atom transistor demonstrated by Park in 2002, which worked like a single electron transistor, but due to with the current flowing throughout a single atom in a molecule with a cobalt atom, and which allows also to observe the Kondo effect. So after this quick overview of the literature, what we are doing in lecture on spintronics. So I saw tomorrow there is also the talk of Professor Rice, and we are collaborating within a European project, the MADIA project, Magnetic Diagnostic Assays for Neurodegenerative Diseases, where the goal is to use magnetic multilayers and to fabricate magnetoresistive biosensors for the early diagnosis of neurodegenerative diseases. And while in the past we worked on nanospintronics with magnetic nanoparticles and on molecular spintronics in the frame of another European project. I'm pleased to show these results. We came from an Indian researcher who was working in my group and concerned about the fabrication of a multi-layer structure with two gold electrodes and a layer of iron oxide, so some layers of iron oxide nanoparticles. And we observed that, as you can see in this image, quite high, a very high tunneling magnetoresistance with a strong dependence on the temperature. So temperature was 10 Kelvin was more than 250%. And we had also a signature of single electron tunneling. This device was large scale with several nanoparticles. Then we miniaturized the device later in a second stage down to having a few nanoparticles in a nanoscale gas. And it was also interesting to observe how these nanoparticles, which prepared in very with a very low dispersion in size, can form huge supercrystals. I can skip this slide. And in well, this is another work that was carried out by another Indian researcher in my group, and where we, in this case we had metal nanoparticles of gold with some molecules around, and we again observed some signature of single electron tunneling, but there was no magnetoresistance in this case. We are also working on semiconductor and oxide spintronics, for example, some ballistic semiconductor devices and multiferroic materials. But let's go now to magnonics. So I like a lot this image that took from Jean-Claude Boudinot from TAI's research group, and where you can see as spintronics presented as a child, the son of the silicon electronics. In the case of spintronics, the main goal is to have current made of spin polarized carriers, electrons or holes. So we have, while in electronics, we have a charge transport, a translational motion of charge. In spintronics, we have a translational motion of spins. But in magnonics, what we focus instead on spin dynamics and on spin waves. So we have, as you can see in this video or in this image, we have magnetic moments which can be polarized, for example, in a ferromagnet, and then the excitation are some spin waves that move inside the magnetic material. So what you can do with magnonics, so instead of using the charge of electrons or the spin of electrons, you can also combine electronics and spintronics to magnonics with some converter to and from magnons, from charge to magnon, from spin to magnons, and you can produce logic gate, magnon conduits, and several devices, also some magnon transistors. But it is also an interesting platform for developing new quantum technologies. And of course, you know that quantum technologies, quantum computers can outperform significantly the traditional computers, thanks to the exploiting the properties of quantum systems, for example, superposition. And in terms of technologies, so for quantum technologies, again, you need, as in classical electronics, you need some system to store the information, something to process the information. And it is possible that you can find a unique material platform material system to do both the operation, but this is not easy. So recently there was a lot of interest in working on hybrid systems and hybrid technologies, where, such as in the traditional computer, you have a hard disk to store the information, for example, in the magnetic domains, and then you have a transistor made of silicon to process the information. You can think to do the same at quantum level. But in this case, you need two systems, and to put these two systems to transfer the information among these two systems. In this image that you can find in this nice review, you can see the excitation frequency, in terms of excitation frequency and coherence time, the different technologies and the different approach that were and are explored worldwide. And for example, using superconducting qubit that have a coherence time from 10 to -9 to 10 to -6, or nuclear spins which can have a coherence time much higher, a mechanical resonator, electron spin systems, that the spin qubit I was showing before, or a microwave resonator, and even atoms, optical and photonic cavities. But what is interesting is that you can try, if you can develop hybrid technologies transferring coherently the information from one system, one subsystem to the other one, which is shown by this arrow in this figure. And it is important. So if everything, if both the system have the same energy, you can exploit resonance resonance phenomena to transfer this information. And in terms of cavity QED, so cavity quantum electrodynamics, this is an overview of the hybrid systems that were produced for quantum computation. For example, using 3D cavities with transmon qubits, or phonons in surface acoustic wave resonators, or paramagnetic spin ensemble, or ferromagnetic materials that can be enclosed in a cavity, and in order to transfer the information among magnons and photons, which are the fundamental excitation of the electromagnetic field in the 3D cavity and the ferromagnetic material. So I can we just mentioned that the physics can be described by means of the Landau-Lifshitz-Gilbert equation. And if you have, for example, the ferromagnetic resonance, you have a precession of the magnetization when you apply an external magnetic field to magnetize your sample, and an RF drive field. And what happens is that you can have a resonance when you are the energy of your RF photons is resonance to the transition in your system. I think I can skip these two. So now, how you can model the cavity with the magnetic material inside, and in particular the magnon photon coupling. You have a confined electromagnetic field in this 3D cavity, made, for example, aluminum or copper, And this can be described by the Hamiltonian you see here. Then you have the Hamiltonian for the magnons, which are the magnetic excitation in your magnetic materials. And then you have an interaction Hamiltonian. So this is the total Hamiltonian, and here you see the interaction Hamiltonian, where you have this coupling strength G. The coupling strength is related to the amount of spins you have in your system. So this is why it is interesting, it is useful to have ferromagnetic materials where we have a large number of a large spin density in order to achieve a strong coupling regime. Indeed, these are the regimes you can obtain in terms of, if you consider this coupling strength and the ratio of this coupling strength with the damping of photonic damping and the magnonic damping in your two subsystems. In particular, if both these ratios are larger than 1, you are in a strong coupling regime. And this is the typical signature of a strong coupling regime with an avoided level crossing, and is like having two oscillators, two coupled oscillators. So is you have instead of when they are coupled, you have it became two. If they are uncoupled, if they are the same energy, you see only one oscillations. But if they are coupled, you have two different oscillations with a gap in between. So in terms of spin density, you see here the spin density in paramagnetic spin ensemble that were the first one to be investigated. This is from 10 to 12 to 10 to 18 spins per centimeter square. While in the Higg, so in the yttrium iron garnet, you have a spin density of 10 to 22. So this allows to reach very more easily a strong coupling regime. There is a very this material is also characterized by a very low damping, high Curie temperature, and it is also transparent to light, so it can be also useful for several applications with already commercial application, but also for hybrid technologies. This is an overview. You can find some details. It is a book chapter we wrote recently, last year. This is an overview about how magnons were coupled with with phonons. You can prepare also magnon dark modes and gradient memories. You can have a conversion to photons, to light, and you can couple this system also to transmodes. So as you can see in all these papers, there is a huge interest in the field of cavity magnonics. So now, what about our activity in Lecce? So this is the system we are investigating. So we have an RF cavity made in aluminum, and then in this cavity we put yttrium iron garnet sphere, which is 1 millimeter in diameter, and everything was placed among the poles of an electromagnet. So you can even do this experiment at room temperature. Then, of course, if you want to go at the quantum regime, the quantum regime, you need to go at in the millikelvin temperature regime. So we investigated both spectroscopic features and time resolved. Performed also time resolved measurements. So these are first signature of first fingerprint of strong coupling. As I told you, is the it is avoided level crossing. that you can see in these two figures, A and B. The first one concerns the mode TE101 in the cavity, and the second one is the second electromagnetic mode confined in the cavity. You can see how if you are far from the resonance frequency of your cavity is fixed, is given by the size of your cavity. Of course, you have several modes, several electromagnetic modes, but so they have specific frequencies. Then, while the resonance frequency of the magnon excitation depends on the magnetic fields. So, if you if the two resonance frequencies are far, what you observe is this line. This is the so if you cut at the fixed magnetic field, you have a peak, and this peak is the resonance of your cavity. While this other line, this other line is the Kittel mode, which is the ferromagnetic, the uniform precession mode in the Higgs sphere, and you are tuning its energy while changing the magnetic fields. When the two energies are the same, you start having a transfer of information among the two different subsystems, the photons and the magnons. And this is the reason of this avoided level crossing. And yeah, you have some. We have cut the different some different spectra at different magnetic fields, and you can see when you are far from the resonance, you only see the photon mode. When you are closer to this avoided level crossing, you see signature of both magnon polarities. So we observed a rich spectrum with several magnetostatic modes. You see, this is the uniform Kittel mode, precession mode, but we have also several other signatures which can be associated to the magnetostatic mode excited in this Higgs sphere. Of course, the identification of these modes is not so you have to work a bit to identify which is each one of these modes, but we proposed a strategy introducing a functional plot variable, which you can see here or on the top. So it's a function of the magnetic fields, and in this way, the left map became the map on the right or on the center. And each mode, you can directly read the mode on your top in x-axis or on the right, and on the right plot. And you can see as there are some modes are present while other modes are not observed. Now is then as a second signature, which is relevant for the application to transfer information, you want to see Rabi oscillations between the photon mode and the magnon mode. And for this reason, we performed time spectroscopy, sending a pulse at a specific pulse which is 3 microseconds large in time, and in this period we send a frequency close to the resonance frequency for having the avoided level crossing at the transfer of information. And as you can observe at the end, when the RF field is turned off, you can see this oscillation, which are also reported on the right. And these are a clear signature of Rabi oscillation and coherent transfer of information among the two, the photon and the magnon subsystem. We performed this at various magnetic for the various nodes from node 1 1 to mode 9 to 9, and also the frequency changed depending on the characteristic of each magnetostatic mode. Significantly, then we observe that there is you can modify it and you can achieve an enhancement of the coupling features by changing the environment around your Higgs sphere. For example, if you put on the bottom a substrate, and you can put a metal substrate or a insulating substrate. And as you can see in this map, with the insulating substrate, we have a much less features visible than in the case of having some metal substrate. And this is not the case just of aluminum oxide, since even if we put MgO, you observe that we lost the central peak and we lost all these magnetostatic features. So our interpretation was that these oscillating magnetic moments are inducing dissipative currents in the metal substrates, and so it is in the presence of magnetostatic modes and when the Higgs sphere is on top of a metal substrate, you can you observe an enhancement of the absorption, and so you can more clearly see these features. Of course, and the other magnetostatic modes. Of course, I can skip this. It is difficult to compare directly these spectra, since as you see, the magnetic field is different where you observe the various features. But with the new functional variable we introduced before, you can change this axis in terms of index of the magnetostatic modes, and you can clearly observe, as in the case of aluminum oxide, there is no the other magnetostatic modes are not excited or are not visible in the spectra. Maybe I can skip this one. And then in terms of time spectroscopy, we observed that the various modes can be show evidence of radio oscillations, but also some coupling among the different modes in the case of which are enhanced when we used magnesium oxide or lead as older, but we are still going in more details in the analysis of these features. So to conclude this part about the results, so cavity magnonics and magnum photon coupling is very interesting for the development of hybrid protocols for quantum technologies. And we observed several magnetostatic modes excited in a Higgs sphere with achieving a strong coupling regime with a 3D cavity. And we observed a metal enhancement of these magnetostatic modes in the strong coupling regime, in combination with radio oscillations. What can be the next steps? So the next steps we plan now, for example, to and we already started some activity in this direction, to use other materials. So materials can be materials having a very low damping to achieve, which is necessary to achieve a strong coupling. So if you want to use different materials instead of yttrium iron garnet, which however has several advantages. Otherwise, it is possible to have also multiferroic and materials and explore magnetoelectric coupling in order to tune the features and have a tunable system, or combine everything with nanostructured substrates, for example, with on nanostructured substrates in magnetic fields, where you can fabricate magnetic crystals to be coupled to the Higg, or using piezoelectric materials in order to couple to photons and have a mechanical and achieving a mechanical control. Just how much time I have? Maybe 5 more minutes.
You can have 10 more minutes. It's okay.
10 more minutes. Okay. So thank you. So I will just mention about a couple of activities that can be of interest, for some collaboration also. So and are related to these perspectives. One is in terms of using surface acoustic waves and surface acoustic wave devices. So what are surface acoustic wave devices? You have you need a piezoelectric substrate, and on top of this piezoelectric substrate, you can fabricate interdigited electrodes and apply an AC signal to excite these surface acoustic waves. The surface acoustic waves are very interesting for both sensor applications and also for storing or producing some protocols for information, for writing the information or transferring the information. Here you can see an experiment we made in Lecce with some delay lines. You can see you have, this is the spectrum in time. The first features depends on the electromagnetic, is related to the electromagnetic wave propagating in the air, while the other two features, which show a clear resonance, are related to the surface acoustic waves traveling in the piezoelectric substrate. You can reproduce it also high order harmonics surface acoustic wave devices, which are interesting for sensing application, and some resonators. So if you combine these systems with some magnetostrictive materials, then you can plan to have a control and to tune the response of your magnetic material. Or you can use, these are our results on colloidal lithography, you can produce large arrays of nanostructured features, for example, nanoholes or nanodisc or nano triangles, which can be made for magnetic application. Of course, you need to have some continuity in your magnetic layer to transfer the magnon, but this can be also interesting if you make them in metals for localized sulfur plasma resonance and for biosensing applications. Or you can combine functional oxides and we can skip this one, functional oxides and multiferroic materials in order to target a control of the magnetism by means of the magnetoelectric coupling. This is some work, to the previous slide, is some work we made in collaboration with a group of Didi Sarma in Bangalore on high-key materials. While here you see some work we made in our lab on multiferroic materials, in particular bismuth ferrite, and materials can be leaky, but if you use, instead of the Sauer tower technique, you use a expand technique, you can have very good, you can get off of the leaky currents and have and measure the right ferroelectric response of your materials. That, of course, depends on the stoichiometry of your films, as you can see here, and in the possibility piezoelectric force measurements showing the possibility to store the information. So finally, I want to mention, since we are affected by these pandemics, and also I saw that there was a lot of interest on in some of the previous talk on biosensors and lab on chip. This is the second activity we run in our laboratory. Just a couple of slides to show that what is our technology. We have impedance sensors, and we have interdigited electrodes on top of a glass substrate with some microfluidic modules, and with these devices, you can. This is a picture of the device we produce in our lab, and you can apply them to DNA, protein, and cell studies for medical diagnostic, food, and environment. And here you can see some of our application in the field of the detection of biomarkers, cancer biomarkers, or cytotoxicity migration and proliferation assays, and also for the food and environment. This can be also you can work changing on the sensing element from antibody, aptamers, molecular imprinted polymers, and nucleic acids, or changing the transducers using the impedance, but also magnetoresistive transducers, such as the European project MADIA with Professor Bunterreis, or surface plasmon resonance, or surface acoustic waves. Finally, I want to go to the last slide to thank people who carried out the activities that I showed. Also, I focused and I included only the people that were working on the magnonic part and are present now in my laboratory. And in particular, most of the work was carried out on the magnonic. On the magnonics was carried out by Angelo Leo, but also Anna Grazia Monteduro and Silvia Rezzato. I thank you, and here's some acknowledge for funding, and I thank you for the attention, and I'm available for questions, and I thank you again to organizer for giving me this opportunity to present our activity at this nice conference.
Thank you, Professor Giuseppe, for your excellent presentation, and hope our participants and our professors, research scholars enjoyed your presentation. And now the session is open for question and answer, and Professor Ramesh will take over.
Thank you, Professor Srinivasan. So there are a few questions, since this being a transdisciplinary conference. There are many questions of various interest. So the first question is, what is magnon coupling phenomenon?
Sorry, what is?
What is magnon coupling phenomenon?
Magnon coupling phenomena. So you can have the coupling among magnons and photons, it means?
The question actually says, what is magnon coupling phenomena? Yeah. Probably between two magnons or magnon photon.
Okay. So about the magnetic moments, the coupling is in term, you can have a dipolar and an exchange coupling. I have a slide was not shown, but okay, this one. I skipped this, but this is a ferromagnetic spin chain. This is an excited state with magnon, and among the different magnetic moments, you can have both dipolar interaction, and exchange interaction. Typically, the exchange interaction are at a much higher frequency in the terahertz regime, while dipolar interaction are in the gigahertz regime. And concerning the coupling among magnons and the photons, throughout these dipoles, which are coupled to the electromagnetic RF field, and which is also you send a RF field in the gigahertz regime, and so you can have resonance excitation.
Okay, thank you. There is one more question. So there are two parts of this question. So how far is magnonics successful in the current technology? Is it commercially used? So this is part one of the question. The second one is, can magnonics devices be controlled by electric field?
Yeah, there is, so for example, here you can see some microwave oscillators and optical insulators which use the EG, electromagnetic and then so it is already some devices are already present and largely present in RF technologies. And while you can produce circulators also. Well, the second part was about the cable, if you can have an electric control.
Yes.
So I can go back to this slide. So here you can see you can have a conversion of from charge to magnons and spin to magnons and so on. So you can, for example, you can also use the anomalous, the spinel effect to couple to the magnons, or you can use magnons to move the spin excitation, and then read it. You can read this spin with a spintronic device, and again you have an electrical signal. So this is possible. That is one of the most interesting aspects of this research for application.
Thank you. So there is one more question. What is the magnitude of increase in the speed in devices due to spintronics technology?
Increasing the speed, so spintronics is a strong advantage of spintronics is to use the spin degree of freedom to store the information. And then if you then have spin polarized currents, you have an additional information which is inside the spin of your carriers. But in terms of speed, it doesn't change too much, and it is in this case with respect to electronics. But you can have much more performing technologies if, for example, you use the spin to store information at the quantum level in spin qubits. Since the spin is a quantum properties too, so you can, if someone is interested, I suggest to read this paper from. There are also some nice review, and in particular the paper from PETA I was showing this before, where you can have a quantum dot system or a double quantum dot systems. You can put single electrons on these two quantum dots. Then you can move the two electrons on the same quantum dots. At this point, we have a singlet state. Then you can separate the two electrons of the different quantum dots, let them to evolve, and measure them back. And then, so you have you are playing with quantum states, and you can produce quantum protocols. There is a lot. There are very strong groups working on these activities. And of course, if you make a quantum computer, it outperforms significantly the standard technologies.
So the last question, can quantum entanglement of photons and electrons can be achieved by using spintronics, which can further be used for information processing?
Okay, quantum entanglement among photons and electrons.
Yes, that's the question.
Yeah, since you can, so there was when we have these hybrid systems, it means we are achieving entangled states, and so you have magnon photon polaritons, for example, in the case of quantum of cavity magnonics in the strong coupling regime. You can do the same also with charge qubits and photons. This was done. It was done also with superconducting, using superconducting qubits. So this is possible, and for who is interested in going more detailed, of course, I am available also to discuss later by email. But I suggest to read this paper on quantum technologies with hybrid systems on PNAS from 2015.
So since the want of time, I will not be able to pose many more questions available here. But if you can answer them, I can communicate to you via email.
Yeah.
Yes.
I can, you can give them my email, and I'm of course available to respond to other questions, also to discuss about possible collaboration on all the topics that are carried out in our group, from spintronics, magnonics to materials and biosensors also.
Okay, thank you. Over to you, Professor Srinivasan.
Thank you, Professor Giuseppe, for your excellent answer from our participants. It was a really useful session, and you are touched upon the topic with the latest development and recent trends. It's really a pleasure to host you in the VIT conference. We would like to collaborate with you, and we are working on MOU between School of Advanced Sciences and the University of Salento and your department, and soon it will be materialized. And my special thanks to the Dean SAS, Dr. Mary Sorrell, and also Professor Rajan Babu for all his wonderful efforts to bring this collaboration possible. And hope we will have a joint publication and research funding also with this collaboration. And after COVID-19, we would be happy to invite you to visit VIT. So we'll be a pleasure to host you again, and look forward very fruitful collaboration with the University of Salento. Thank you so much, Professor Ramesh, for coordinating this session in a wonderful way. Thank you so much. And I think the next session will start very soon. Thank you. Bye-bye.
Thank you, sir. Thank you.
Thank you, Professor Srinivasan. So on behalf of the organizing committee, I would like to thank you for chairing this session. Thank you very much. And also thanks goes to Professor Maruccio for the information given in terms of quantum technology. So we would definitely love to contact you for future. Thank you so much.
Thank you, Professor.
Thank you.
So participant, we have the next session scheduled at 4:30. So we will start the session in a couple of minutes.
Thank you, Professor Giuseppe.
Thank you again for the invitation, and
yes,
we will in touch for
sure.
For the agreement.
Yeah, sure. Bye.
Bye.
If possible, please continue the sessions. It is up to you.
Okay.
Yeah, thank you.
Professor S. Babu.
Yes, sir. The next chair has come.
Yes, I think he has to unmute his mic.
One minute.
Yes,
Yeah.
I think now. So
Good evening, sir. Good evening.
Yes, sir. Welcome, sir. Welcome.
Thank you for the
So
invite.
we'll start this session in a couple of minutes.
Yeah. So our invited guest, Dr. Mukesh Kumar, has joined.
Yes, we need to.
Yeah, I think so, sir. Let me check, sir. Should have.
Dear participants, there is a couple of minutes of delay here, but we will start the session as soon as our speaker is available for us. He has to just join the Zoom platform. Please bear with us.
Yes, hello.
Yes, hello. Is Professor Kumar Mukesh?
Hello.
Hello.
1 minute.
Hello.
Hello, good afternoon.
Yes, I can listen now. Sorry.
Can you switch on your video?
Access to share the screen, please.
Yes, please. Yeah.
Hello.
Hello. Yeah, please share the screen. Yeah. Yes, we can see your video. Just share the screen.
Okay, it's now to do it.
Yes, we can see this.
Hello, can you listen to me?
Yes, yes, we can see the slide and listen to you.
Okay.
Is it fine now? invite the chair to introduce.
Hello. Hello, can you listen to me?
Yes, we can listen. We can listen and we can see your slides.
Yeah.
So can we start the session?
I'm really sorry, I can't listen anything. I just wonder if anyone is listening to me.
Yeah, we are able to hear you. We are able to also see your slides. Are you hearing Dr. Mukesh Kumar? Are you able to hear?
Hello. Okay.
We are able to hear you.
Okay, so I can stop because it looks like a single thought later on that one. First thing, apologies from me because I thought I'm starting at 1:30 UK time, but it looks like my time calculation was wrong.
That's fine.
So,
that's fine.
apologies on that. My name is Mukesh Kumar. I am faculty member in Department of Engineering, and I work, do research in one of the divisions, which is called Institute for Manufacturing. And today I will be talking about global food security challenges and the nature of research, which requires multidisciplinary approach, which is the key theme of this conference.
Sure.
So going back to the presentation, which you are seeing,
we will have a
hopefully
we will introduce you to the audience if you are able to hear us.
Yes. Hello, can you hear us? Can you hear me?
Yeah, we can hear you. Are you able to hear us?
Yes, now I can hear.
Yeah.
Completely.
So we wanted to introduce you to the audience.
Okay.
Formally, and then we can go ahead with the presentation.
Okay, fantastic.
Yeah. So very pleasant evening wishes to one and all present here. It is really a pleasant evening in Vellore. I don't know about other places. And I also wanted to wish a good morning to the delegates and as well as the speakers who are from the middle and the eastern part of the world, western part of the world. So I am happy to chair this session, which is basically on global food security from supply chain perspective, the or the transdisciplinary research perspective. I would like to thank and congratulate the organizers, Professor Rajan Babu and the Dean School of Advanced Sciences, as well as the team for choosing this particular session in this transdisciplinary conference, VITC 2020. Because this is a very important present day topic where the transdisciplinary approach is very much required. The interventions of the engineering faculty and the researchers, as well as the big data analytics, business people are all required to ensure the future food security of the globe through an efficient supply chain management. We have a wonderful invited expert here today with us, Dr. Mukesh Kumar from Cambridge University, UK, who is basically working in the Institute of Manufacturing in the Cambridge University. And when I went through his profile, I'm so surprised that he has worked at different positions in different research programs of the government of UK, as well as he is also collaborating with various institutes, including the Climate Change Mitigation Research UK, then Karlsruher Institute Germany, then Turku School of Economics Finland, as well as many IITs in India. So he mainly focuses on understanding of industrial resilience and sustainability, issues of food supply chains, as well as distributed manufacturing and many other areas. With his vast experience in this area and also his thoughts for the future directions where the international level collaborations in the supply chain management and the transdisciplinary approach should go forward will enlighten the audience, as well as we are also excited to hear from him his thoughts. And I hope this session will be very useful and very productive. And with this a few introductory words, I would like to invite Dr. Mukesh Kumar once again And thanks for joining us in the midst of your busy schedule to share your thoughts with us. And now I hand over the session to you, sir, for the presentation. Thank you.
Thank you very much, Professor S. Babu. I'm again would like to apologize for this delay because of some time difference. I couldn't understand. My computer was showing something else. I would like to go back again on the topic of global food security, and it's from the supply chain perspective and the nature of research that requires to solve this challenge of security of food. But before I go, it's better to give a little bit idea about where I come from, because we are coming from very diverse background. I'm very thankful for giving such an illustrious introduction of mine. So I was talking about, I think it's already been known that I come from Institute for Manufacturing. And what we do in Institute for Manufacturing is we do research divided into the area of technology, management, and policy. We have education, where we do undergraduate teaching, master's teaching, and PhD. Almost around 80 PhD students that we have right now. And then we do knowledge transfer, which is exactly the problem in the morning. IIT Delhi director was talking about is how you translate the research. Research should not start from library and end up in the library. And that's the area that we are quite good, and we do various work along that line. As a snapshot, we have around 17 UTOs. UTO is the position that Cambridge University has, which is a common position for any academics. It's called University Teaching Officers. So we have around 1,600 UTOs across the university, and 17 exist in our division. Again, 62 researchers, 28 visiting researchers, and again, various students that you can look at. That's the snapshot. We publish papers, of course. We write books. That's the job that we have. But remember, we are more into translation of research as well. And all these activity is funded by internal and external grants and various funding bodies that we work with. From the research perspective, which is also reflects our teaching as well. So from research, the core of our work is around manufacturing processes, which looks at inkjet research, which is about 3D printing kind of concepts, industrial photonics, again, looking at laser-based manufacturing, nanotechnology, and fluids in advanced manufacturing. These are the core part of our technology-based research, which leads to a manufacturing system level research, because these manufacturing processes sits across the factory, where we look at lean concept, quality, operations management, data, simulation, and some of the areas that I contribute in manufacturing system. But also this factories also exist in an organizational system, which is a business, where we also focus on innovation management, strategy, and organizational structure. And then again, businesses also exist in ecosystem, which is looking at industrial sustainability, international manufacturing policy, and all these things. So again, our research teaching is based on this particular framework that you are seeing right now. What we do in IFM, again, we have research, we have education, and then we have a customer, which is government, industry, and universities. But again, remember, all these research and education needs comes from government, industry, and universities, and that's how it works. The conventional model used to be linear, but now this is much more circular. Coming back to the topic of global food security, because that's the most interesting topic these days. Food security has become one of the challenge that every institution, global institution, and government are working on. What are the key dimensions? Global food security dimensions, people talk about whether food will be available for us, especially for 7 billion or 9 billion population in the future, to eat or not. Even if it's available, whether it will be affordable or not, whether people can buy it or not. And even if they can buy it, whether it will be safe or not. So safety is another bit. And at the end, what food provides is the nutrition. So whether it will be nutritious or not. So these are the challenges. But then there is another bit which we are looking at is sustainability, whether it will be sustainable or not, whether it will be produced at the low carbon value and the low emission values. These are the biggest concept of global food security. And when we look at in Cambridge global food security, what interesting things comes back is to us is these global food security problems are tackled by various institutions or departments, such as plant sciences, archaeology, human nutrition, land economy and climate change, geography, geology, veterinary, and supply chain and industrial sustainability, where I come from. And this supply chain and industrial sustainability is a part of engineering discipline that we are looking at. So what we have understood till now is if we are trying to address a global challenge such as food security, we need to look at this problem from the various perspectives. So when we talk about availability will be compromised by climate change. Availability can be compromised by various other risk factors. Affordability is more about whether the cost factors will come into the picture or not. And all these things, when we look at, is about different disciplines coming together. So give you an example. There are $680 billion worth of food that we throw, which is around 27% of global food production. And around, again, 1 billion population is going hungry every day. Even if we solve that food wastage challenge, we can feed 1 billion population who is going hungry. So these are the challenges that we are looking at that we need to solve. And in order to solve it, it's not about the farmers has to solve it, the weather science has to work as well. So various multidiscipline has to come. So again, these challenges that I have mentioned, we have greenhouse emission from food system coming around 19 to 29%, leading to contributing to global climate change. Product safety, we have contaminated food. Every year, 600 million people almost get sick. And out of that, 420,000 people die because of contaminated food. Even though we have a good system in the UK for food, it means UK should not have a malnutrition problem. But UK children's been identified that they are lacking nutrition, especially the micronutrients, not macronutrients. So it's a malnutrition when we are looking at, it's a global problem. And there are two types of problems associated with that is underweight and overweight. Huge wastage I've already mentioned. And climate change is compromising food availability because certain parts of the world is not able to produce the amount of food, and also crop failure has become quite dominant feature. When we look at greenhouse gas emission, average food consumption, you can look from different product type, meat, dairy, poultry, and people who are eating meat, they are contributing it more. And here is the picture of generally, I give this picture to my student. I say like, okay, this is in 1900. Lots of people, around 2,700 people got sick in England by drinking beer. And around 57 people died. So it was the case of beer having arsenic water. And because of arsenic water, people are getting sick and died as well. So it's a food safety issues in 1900. Since then, we gone through various industrial revolution and industry 2, 3, 4, and right now we are industry 4.0. So idea is that, okay, we should have solved this problem of food poisoning. But last year again, a girl, 16-year-old girl died by eating a particular kind of sandwich and having a nut allergies because of that. So from 1900 till 2019, what we didn't do rightly, that we still face this kind of problem. And that kind of thing that I am particularly interested in. And simple analysis, when we look at what we found out, that supply chain has traceability concept. So people have worked on the different data. But current data system that people have worked and the same data architecture they still use with the certain technologies such as blockchain is not solving the problem. A problem requires a fundamental way of a different way of thinking, and data structure archetype is needed, which is new. So sometimes people try to address the problem, but there is no data because data is not being collected. Data do exist, but not being circulated or collected in the right form. So this particular example is just talking about existing data archetype in supply chain is not fit for solving sustainability challenges or challenges of food industry. So what it leads to, it leads to the ontology research of the computer science that we need to start looking at, a different discipline, which can certainly contribute to this particular area of food security. People has to come and work together. So one of the messages that I give all my engineering students is technology is necessary, but not sufficient. In order to make technology work, we need to do multiple things. The second example that I would like to bring your attention to look at multidisciplinarity approach is climate change. Climate change, it's the story which started in 2011 in my life in Cambridge, when a scientist in British Antarctic Survey met me in one of the conference and asked me, Mukesh, we know climate change is happening. It's human-induced climate change. We are telling the world about our science and the temperature will increase. Something will happen and it's not good. But industry is not really being serious. They really don't want to know. They don't know what to do. How, Mukesh, we can work together to convince industry to take it seriously and try to prepare for it. Prepare for it for two ways. One is about slowing the speed of climate change. Another one is adapting into the new weather system. That was all fantastic. And suddenly we've also found a trust which was funding this research. This is a good example where climate science and the Department of Engineering coming together in order to understand the climate change impact on industries. And we devised a particular project which looked at extreme weather. So climate change, 100 years, certain degrees of increase of the temperature. But there is another aspect of climate change is during these changes, there will be extreme weather events. And we picked up that particular events and we started investigating with climate scientists. To our surprise, it was quite astonishing to know that everyone doesn't have the same definition of extreme weather as well. But while doing this study, we looked at companies and tried to map out their supply chains and look at certain types of extreme weather, such as quick droughts, heat waves, storms, heavy precipitation. This is the example of one of the UK company, food company, from farm to customer outlet. The top is one is the network structure. In the middle, what in each network people do, such as land preparation, cutting, sowing, and kind of things. And the bottom one is the very simple concept of the value structure. And what we found out that more than 70% of the company's value was affected by extreme weather events. So this is one example, one more example of how different disciplines can come together to solve the challenge. Based on this research, companies are right now making plans to invest in different zones, climatic zones, where different weather inputs can help them not to break their supply chains. The second example is about this food supply chain, looking at food wastage. And this is another bit which is interesting. It was almost, in Cambridge, we never force people to do something, but we are encouraged to do it. And I was asked to look at potato supply chain, which I never had any experience. I was like, what potatoes? Potatoes, there are 2-3 types of potatoes that we can actually look at. And what is interesting in this one, but to my surprise, potato is the second highest wasted vegetable or food item in UK after bread. from academic point of view, I thought like, if I can link the types of potatoes and types of wastage, I can solve these problems. If this relationship is understood, we can really solve the problem. But it's not as easy as it seems. There are 4,500 varieties of potato exist in this world. It's difficult to actually create that kind of relationship. But here, the plant science department also helped a lot to us. So I'm just giving you a picture of a first potato variety that came by Charles Darwin, who bring it from outside to UK, and it's in Cambridge Herbarium. If you get chance to visit, you can see that particular plant variety, but it's already been lost, this variety. And here is another potato picture. This is actually 500 years old mummified potato, again exists in Cambridge, one of the museum that we can look at. And what we have found out. So we have found out that in the UK, we grow 5 potatoes to eat 1 potato. Almost, if we throw 1 kilogram of potato, we almost throw in 270 liters of water. And then we also understood where these particular losses happens and why it happens. And again, what it demonstrates, the different discipline, the social science, which looks at consumer preference and consumer behavior, engineering and different plant sciences has to come together in order to reduce some of these losses. We don't need to grow 5 potatoes to eat 1 potato. We can grow 1 potato to eat 1 potato. That's the bit that we need to be working on, which is quite important, that we should be focusing on these things. Here is the example of another discipline that comes together very quickly on this one. This is a village called Thakurgaon in Jharkhand. It's around 40-50 kilometers far from Ranchi city. And here some of the pictures I took. So the first picture, you can see myself with one of the farmer. In the second picture, you can see a water well is filled by water, which is quite strange. And there is another person who is the farmer on the document, but he's not the farmer, he's the landowner. What actually demonstrated, I went to Thakurgaon to understand what is the cost of farming. While looking at all these things, the hidden cost of farming is much more higher than the price that farmers actually gets. And all the subsidies that government gives is not enough. The middle picture shows the sustainability dimensions. We can criticize these farmers that, okay, why you are storing water in the dried water well, but there is no other infrastructure or investment in this area. Unless until these particular infrastructure and investment comes, it will be very unsustainable farming. At the same time, I also learned about different circularity practices in Indian farming, which was interesting. If I have more time, I can tell you more that story, but I would like to quickly move to another part, which is looking at circular economy. Circular economy is understood to be one of the key concepts of sustainability in food security. People are talked about how we can reuse, repurpose, repair, remanufacture, and recycle. In this area, I am working quite closely with Nestle and various other companies to look at how we can create circularity in food systems. A problem that we actually face in this area is not about how to create a reuse system. People have the understanding how to create a reuse system, but people have very less understanding about how to design a supply chain, which is replicate the reuse system. Once it's been reused, how it can move to different types of circularity, such as remanufacturing, recycling kind of concepts. And that makes a quite interesting bit that various disciplines has to come together from the material science perspective as well. So what we are talking till now, we are talking about, okay, we need to map out, understand food system. We need to look at multiple interdependent challenges. The challenges are connected with each other, but that requires different disciplines to come together. We're also looking at the points such as technological solution is a part of the solution, not the whole solution. So engineering department can contribute to some extent to these areas, not all the extents. Different discipline has to come together. And last one, we need to think about transforming this food system, which is very, very unsustainable right now, and it's not giving the desired outcome of the food system. So looking at these bits are really, really important, and I really would like to encourage all of you. I know most of you, majority of you are from the physics department, but there are bits from the physics which can certainly contribute to global food security. And I would like to encourage you to work in this area, because this is the biggest challenge that we are facing. If you have any particular issues, and come and talk to me. There are various contact points that you can look at my slides. You can write me an email and be in touch. Thank you very much. I think I've tried to shorten my presentation to compensate the time that I lost at the beginning. I welcome any questions that people have to talk to me. Thank you.
Thank you so much, Dr. Mukesh. Over to Dr. Babu. So if it's not, I can continue. There are a few questions, in fact. Yeah. So can I ask a question from the audience?
Yeah, thank you very much, Dr. Mukesh Kumar, for the wonderful sharing of your experiences and thoughts, and inviting all the disciplines to take part in the supply chain related things. And Dr. Ramesh, if there are any questions from the audience, we can.
Okay, so there is one question from the audience. Yeah, he asks, is the food production is the correct question, or sustainability is the right question?
Both are the correct questions. So current food production is unsustainable. And that's the thing that we need to look at. If I understood that question correctly, but this is quite important, that we don't need to distinguish that these are the two different concepts. Sustainability sits across any system, and food system, of course, is one of the biggest contributor.
Okay, so if I may add one more question to the same question. So how do we communicate to the farmers in these kind of sustainability issues and quality of the food production when their whole idea is to grow and sell?
Very interesting. I think I can tell you about from my perspective, visiting in India farmers and also in Ethiopia. It's basically we need to ask questions and make them comfortable and learn their own language rather than using pure academic language, trying to understand how the system works. Give you a very simple example. This farmer who is in the picture right now, you can see. It looks like very illiterate person, but he is the best practitioner of circular economy. As you know, the left out of the wheat plant can't be eaten by the cows or any animal. It's not nutritious for them. It's not tasty. So somebody has to throw it. And you know, in India, in Punjab, in winter season, the problem of burning these left-outs and creating more pollution. This particular farmer, what he has done, very interesting, is he also grows cucumber. And because cucumbers grows in the rainy season, cucumber plant is so tiny at the beginning, when they actually put the seed, the water drops damage those particular plant. So what he does, he actually spray all the left out of the wheat plant on the field and let the cucumber grow. And that saves actually the plant, and it grows very nicely. But there's another benefit of that one is you might have seen this cucumber have two kind of color. One is pure green with the white patches, and there is green with the yellow patches. Yellow patches generally comes because if cucumbers touches the soil and it takes the soil color. As a consumer, we get the perception that this is actually not a fresh cucumber. But actually, if you grow with this circularity concept, means like the wastage of one product, which is the wheat here, is being used to grow cucumber in a way that it creates the higher yield, but at the same time, it gives the better look. He gets the better price in the market. So it's about understanding and talking to these farmers is really, really important. For me, I learned a lot by just understanding how much it cost them to produce cauliflower or 1 kilogram of wheat. And still there were lots of hidden costs were there. These farmers were not putting their wife labor cost, their children, which is generally the female child labor cost into the farming.
Okay. There is one more question from Mr. Girish. So he asked, at the current rate of population explosion, how long do you think it will be before we run into global food scarcity? How do we overcome it?
As I mentioned right now, we don't need to actually increase the food production. We are focusing into a completely wrong area. We are wasting a lot of food, and I told you almost $680 billion worth of food that we waste. If we don't waste that food, we can feed 1 billion extra population. So idea is not to actually cut down the forest, increase the more production areas of food. It's about how to make the existing system, which is very unsustainable and inefficient, and make it efficient. That's the idea that we need to work. And that's why various discipline has to come together, because if we're just going to cut the, make more filled farms and farms, we don't need to have multiple discipline coming together here.
Dr. Mukesh Kumar, can I ask something?
Yes, please.
So, this is about the price, what the farmers finally get. What you talked about is a very important point. And so in certain situations, because of the non-profitability nature of selling the produce, we have seen many times the farmers are throwing their produce on the roadside. Particularly, it happens to tomatoes when the prices fall, and other vegetables. During the COVID also, since it is a lockdown period, the watermelons were, the farmers who have grown watermelons were unable to sold, and they have just thrown away. So how do you take this, and what kind of policies should we derive to curtail this issue?
And this is really important question, and that comes back to this whole value creation concept. So right now, farmers are selling a particular food product, and if suddenly some disruptions happens, this product lays at one particular price, and they don't have any option then rather than throwing, and it happens across India. What about if we had a nearby food processing plant, which can make watermelon juice, can store it, you can create the longevity of that particular product. You can add value and get extra money on top of that. And then these farmers have seasonal unemployment as well, which can be tackled by these industries. Currently, these other things are not available to these farmers, and especially some of the eastern part of India, food processing industries are not well established. So some of these food product has to go to different part of the country to get further processed. So idea is how we can create value. The second part, why farmers earns less money. I just wanted to bring one particular statistics. In UK, we spend almost 500 million US pound. This means $500 million British pound on nutrition product. Where we buy this particular product is from pharmaceutical company. But where we should be actually getting this particular nutrition should be from the farmers. The day farmers will stop selling rice, cauliflower, and other vegetables, and the day they start selling nutrition, I think they will earn the money. The problem is we haven't solved the problem, how we can actually evaluate the nutrition at the farm level and maintain that nutrition to the consumer level. And then consumer are being aware how this nutrition affects their body and health. And the day we start understanding these bits, I think the farmer's life will be better, and consumers' life will be, of course, will be better, because they will be eating the right nutrition food.
Yeah, excellent. Thank you.
If I may ask one last question.
Yes, please.
Yeah. So most of our participants are either students or university students, for example, who will be the pillars of the next generation society. So what sort of message you want to convey to them?
I think for students, two things. Some of the multiple students have multiple objectives. One might think about, oh, I need to start up and start looking for jobs and earn money. Those who are thinking about startups, they just need to think about, can we create a startup in the area of food waste? They just 600, again, going to repeat that number, 680 billion US dollar food, we throw it. Somebody has to just catch it and create value out of it. So it's been thrown, it's there for you to take it. Similarly, in pharmaceutical industry, $1 trillion worth of counterfeit products are there. If you can solve that particular challenge, you have $1 trillion for you to grab it. That's the money aspect of it. Those who want to work in the factories and companies, think about in your own company, what kind of wastages happen, and never try to close the eyes, because even in UK, in food factories, there are 16 to 26% wastages that happen in the factory. So although we say like a Western country, UK is very efficient, but it's not. If you're looking at these particular factories, if you're going to work in these organizations, look at the wastages, and you may find it that this is a very high value if you don't do this particular wastage. So in both areas, with skills, solve this problem. Creating organization, you can scale it up in finding solutions and also capture the value while doing it.
Okay, thank you.
Yeah.
Over to you, Professor.
Yeah, one more point, Professor Mukesh Kumar.
Yes.
Since it is a little bit delayed, let me introduce the chair of this session is Professor Babu. He is Dean of our Agriculture School.
Oh, fantastic.
That's why he is a chair of this session. I think Dean is happy for this session, sir. Am I correct, sir?
Yeah, sure.
Thank you, sir. Thank you for chairing, sir. Please continue, sir.
Really informative, and it was a nice blend of engineering, science, technology, policy, as well as the societal importance in this particular session. That was really very, very useful, and particularly your last answer, motivational things for the younger generation. That was really an eye-opener, I guess. So I would like to thank you sincerely on behalf of the organizing committee and the VIT, and we look forward to further collaborations, because we are working in a transdisciplinary way, and agriculture is a new school in VIT. It's just 3 years old, and we wanted to take it forward and collaborate with you, sir. So we will be writing to you and looking forward for further interactions also.
I just want to say 2 words. VIT, I came to know a lot from my IIT colleagues that I work with IIT Bombay, IIT Delhi, Kharagpur. And Vellore Institute of Technology, it seems to be, is growing by name, by years. And its reputation is well known. Before coming to Cambridge, I was not knowing about VIT. So it's because of my Indian colleagues really talked about it. So it shows that VIT is known for research and in education is growing quite well. I didn't know about the VIT has this agricultural dimensions as well. And I would be very happy to do more work and create some more awareness and collaboration into this area. My services are available anytime you need, Professor Babu, of my any particular help. I'm happy to be there.
Sure. Thank you. Thank you very much for your positive response. I once again sincerely thank all the participants for joining in this session and having enlightened by this wonderful talk by Dr. Mukesh Kumar. And I thank all the organizers for the opportunity also. Now with this final remarks, I request Dr. Ramesh to give the concluding remark for the session.
Dr. Ramesh, before we wind up, just I want to say thanks to Dr. Mukesh Dr. Mukesh, really, we are so much impressed on your talk, and thank you for giving us an opportunity. And this is the place where I have learned so many things in IFM in Cambridge. Yeah, the place you are showing, I never forget about that. And the interaction which I had during my stay in Cambridge, that's why this introduction of IFM at VIT. This is the initial stage of beginning a cooperation between VIT and Cambridge. This transdisciplinary research will brought you more laurels to both VIT and Cambridge. And I hope that the days to come will have more interaction. Thank you, Dr. Mukesh, for accepting our invitation. You were there in the morning session also. We are so thankful. And probably we'll have physics, YL, and IFM. We'll have a collaboration in the days to come. Thank you so much, Dr. Mukesh.
Thank you, James. And your wish is my command.
Yeah.
So thank you so much. So at the outset, I would like to thank Professor S. Babu, the Dean of Agricultural School here in VIT, for chairing this session. Thank you so much. Over to Professor Elil Willi. She has some important information.
Thank you, sir. Dear participants, now we have oral presentations. As we mentioned in the program schedule, we have two parallel sessions, session 1 and 2. Kind attention to the presenters from session 2 with the theme of crystal growth and magnetism. You are requesting you to come with the respective Zoom link which was sent in your mail. Formally, we are closing the invited lecture session now. The next session will start tomorrow at 9 a.m. Requesting you to come and join 10 minutes before the session starts. I wish you all every success in your deliberations and participations. Thank you. Thank you, sir.
Hello, Debashis.
Check the audio.
Arun, sorry, Ankur. Unmute.
Yes. I think my voice is okay now.
Yeah, that's okay. Thank you.
Great, sir. Very good evening to sir, Padmanabhan sir, Ramesh sir.
Yes, good evening.
Rajan Babu sir and Professor Giuseppe. Very good evening to you.
Good evening.
Good evening, Professor. Welcome.
Good evening, sir.
Good evening, Babu sir.
Thanks for inviting.
Long time no see. I think it's good to see each other once in a while before we start looking different.
Padmanabhan, good evening.
Good evening.
Okay, welcome all you in the session 1 of the oral presentation. So we have our 3 invited judges, Dr. Padmanabhan K from School of Mechanical Engineering and Dr. Jiten Satija from the School of Biotechnology and Dr. Debashis Mishra from School of Bioscience and Technologies. So participants will be having 8 minutes for the presentation and 2 minutes for the question and answer. Please, I will request participants to unmute them and they can share their slides. If you have any issue, just you can message us. We will take care of that part. And I would like to request Dr. Jiten, please start with the session.
Thank you, Dr. Ankur. We'll start the session with our first presentation, that is by Mr. Ruben Venish. The title of the presentation is Success Stories Behind How 3D Printing Technology Responds to COVID-19 Pandemic. So may I request Mr. Ruben to please share the screen?
Yes, sir.
Thank you. Welcome, Ruben.
Thank you, sir. Very good evening, one and all present here. So I want to share a success. There are many success stories behind how 3D printing technology responds to COVID-19 pandemic. For time concerning, I am going to share a few case studies how this 3D printing technology helps to tackle COVID-19 pandemic. So I want to share one example that I heard from my own friend who is in one of the Caribbean island. It's called Antigua. So where there were no ventilators. I think National Hospital, there are only two ventilators and COVID people, many people affected by COVID-19. So that time they have used T connector or oxygen splitter. They could able to, which is designed and developed by using 3D printing. Then they could able to split the oxygen and distribute to the patients, and in that way they could able to meet the situation. And then by using the same 3D printing technology, they have designed some venturi tube and other respiratory apparatus. So in this way they have handled. So this COVID-19 is a really tough challenge for every one of us in terms of economically, and there are people really affected. And corona pandemic has unfurled its wings to disrupt the healthcare system throughout the world, starting from United Nations, like developed countries, to even underdeveloped countries. And there are few things really required for everyone, especially to meet the COVID-19 pandemic. So especially personal protective equipment, PPE kit, as well as respiratory equipments like a ventilator and those components. So, and apart from that, the testing kits like swab test. And so these are the key components of COVID-19. So in that way we can identify and we can handle and we can at least protect ourselves out of this pandemic. So the FDI NIH 3D print exchange in United States, they have designed N95 mask by using 3D printing, which help to tackle the situation in that area. So they could able to print a N95 mask almost 3,000 per day, and they have meet at least 30,000 people's need of mask within 10 days in a particular city. So I just want to explain what is 3D printing. So many might have heard about 3D printing. So 3D printing is there are 4 steps. So we can get the component by using 3D printing. 3D printing is it is also called additive manufacturing. A component or model can be designed layer by layer, and each layer depends on the process parameters. So if we have a 3D CAD model, or if we have a design, and we have to choose the right material, and the right material will be built by using layer by layer technology. Even that material based on powder or liquid or solid, and afterwards the printed model will be tested and evaluated the performance. So when the pandemic hit, and we heard many things from Italy, and Italy was really shortage of hospital respiratory, especially ventilators. So that time there is a local Italian startup, Isnova, successfully developed to print venturi valves, and they have meet out the ventilator, then the requirements of ventilator and its components. And they have designed and developed this ventilator component by using fused filament fabrication printers. And there are other 3D printing technologies like this is the very cost economical one, and there is another technique called fused deposition modeling. These two methods used to print cost economical components. And another one is I have mentioned a 3D printer, a ventilator splitter. There is a T connector using in place more than one patient in a mechanical ventilation when the number of patients who need invasive mechanical ventilation exceeds the supply of available ventilators. And the usual medical standards, it won't permit, especially in US, but this is the critical time, and the number of ventilators and the patients are, when the ratio is going up, to interest in the preserving the life of the patient, this standards, this 3D printed T connector has allowed by.
நீங்க தான் செஷன் 2 ஹோஸ்டா?
And next one is
ஆமா, நீங்க தான ஸ்டார்ட் பண்ணீங்க செஷனை.
optical respiratory
parallel session
apparatus. Another one is non-adjustable venturi valve. So this also designed by Illinois Arabic design. So this one they can control and adjust the oxygen level. If the
sorry to interrupt you, Ruben. Ruben, your voice is not clear. Can you speak little louder?
Yes, sir. Yeah. Yes, sir. Yes, sir.
That's better.
Yes, sir. So in Europe and United States, there is a creation of 3D printed ventilator splitters. It is same like a T connector, and there is adjustable flow control. So they have put the project name as No to COVID-1 valve. So this valve used to help the patients, like a single ventilator can be used for multiple number of patients, and there is a oxygen flow control, and they can if the oxygen requirement is less, there is adjustment. The valve could able to adjust based on the patient's requirements. And this is the 3D printed ventilator. There was a testing happened. And next to ventilator, there is another one. It is personal protective equipments. So as we know very well, and we have witnessing, and nowadays air travel is started. So we could able to witness people are using eye shield and face shield, gown, mask, and gloves. Most of the items are efficiently made and managed by using 3D printing. So we can able to see a person who wears gloves, goggles, face shield, and mask. This all made up of 3D printing. And this is the mask made by 3D printing from machine Argo 500. It is fused to filament by using fused to filament fabrication method. So this is CAD model, and this is the face mask produced by 3D printing. And we have seen almost 6-7 months. There were numerous types and designs of face masks have been proposed by the individual users, researchers, physicians, and commercial entities. And so based on
again 1 minute. You are left with 1 minute.
Yeah, sir. Thank you, sir. And there are so many designs proposed by the researchers, and there are two companies, Copper 3D, NanoHack, and HEPA. They have demonstrated, and another company very recently added, it is Mask, and they are like a user-friendly mask. Sometimes the people having respiratory issues, they could not able to use the mask. So they have designed user-friendly mask, and these masks produced by using polylactic PLA filament. And apart from these basic apparatus, like we often used to touch the surfaces, like for example, if you open the door, like for example, if you use a door of a bus or ATM or our house, there is a 3D printed handle opener, which usually avoid to touch the usage of usage by many, avoid the usage of many people. So in that way, we could be able to protect ourselves from these COVID viruses. So there are so many success stories happening every day by efficiently using these 3D printing technologies. So we are hearing every day there are many people dying and many people are suffering, and the media is from the media, but this 3D printing technology helped this humanity, especially in this pandemic, to overtake and to bring the hope how to handle and how to overcome and how to manage the worst situation of this pandemic. Thank you, sir. Thank you for your patience and listening.
Thank you, Ruben, for such a wonderful presentation and summarizing about the 3D printed technology which has helped develop in this COVID-19 crisis. Now, I request Dr. Padmanabhan to ask few questions. We have only 2 minutes.
Like, what attracted you to 3D printing, and then what is your contribution in this?
Actually, basically, I'm a mechanical engineer, and now I am working in a chemical company. The thing is that, like, it directly affected my company. So, I am not contributing directly by using 3D printing technology, but there are my friends, those who are working in 3D printing directly involving making components like face mask and face shield and goggles, and they are supplying to some companies and cargos like Indigo. So I could able to work with them during this pandemic, like 2-3 weeks, and I could collect the data, and that really encouraged me to learn about these things.
So it's just some kind of a summary and review collection, literature collection. Is some kind of a review and literature collection.
Right. Dr. Devashish, if you have any questions.
I have a simple technical questions. He's told that people have made gloves out of 3D printing also. Now, can you explain what 3D printing technology they used for making gloves?
Sorry, sir. Actually, gloves. There is. Actually, I have added gloves also, but it is not.
Okay.
In PPE kit, except gloves, other elements, other components are made by 3D printing, and most of the PPE kits are produced through fused filament fabrication.
Yeah, the hard plastic parts, that is possible.
Yes, sir.
Not the shield part. The shield holder you can make it out of PPE. 3D printers. Not the transparent part. 3D printing cannot give you so transparent things.
Yes, actually, and there are other components can made by using fused deposition modeling, and afterwards it will be assembled together, and we can get a final component, final part.
Thanks, Ruben. Thanks, Professor.
Thank you, Mr. Ruben. Thank you for this presentation and answering the questions also. Now, I would like to invite presentation. For the second presentation, Dr. Balamurgan KS. And the topic of the presentation is design a wearable IoT devices using pressure sensor for fall avoidance by human movement monitoring system. Dr. Balamurgan.
Very good evening to all.
I request you to please share the screen. You have 8 minutes for presentation, and it will be followed by 2-minute question and answer session.
I'd like to thanks to organizer to provide me opportunity to present my proposed system design a wearable IO device using pressure sensor for fall avoidance for a human movement monitoring system. Nowadays, the above 60 age people community strength is increasing, and the fall risk-free accident happen in the, as per the survey, the accident happen is every year increasing. So that the seamless monitoring the human activities is the more important in a problem in a nowadays. So the wearable IoT device is the useful solution for continuous health monitoring, analyzing behavior of the people and fall detection. This is the general solution. But my proposed system, human movement monitoring by using the pressure sensor for avoiding the human fall, and it also monitoring the human activities based on the statistical data using the machine learning language, support vector machine learning algorithm in my proposed system used to generate the report to avoid the fall detection in the future. In all existing system, the only predict the fall will happen or not. They not provide any solution also. Some research paper provide the solution to provide the air cap back like that, but it will accuracy is very less. Due to the machine learning language and cloud data, my proposed system before before fall happen, it trigger the air cap to avoid the any injury occur in the human. Okay, this is the my main objective. Okay, this is the my system overview. Here I used the two pressure sensor. It is a footwear sensor. It is available in the market. But here it is the left leg. I wear the one pressure sensor, another right leg. I used the another one pressure sensor. Two pressure sensor always measure the pressure of the human. It may be either left leg or right leg. Based on that, person walking, based on the press, we can identify person walk or sit or stair gauge. Like that, we can identify. Okay, this algorithm I generated, I implemented using the machine learning. The same way, the heartbeat also we can measure. Pulse rate, due to measure the pulse rate and any surrounding occur in the circumstance, that also with the help of the sensor I am observing. Okay, the most of the research paper only getting the data from the sensor, one type of analyzing for the fall care system. Another one, there are using the camera in the home or a human dangerous area, like that, capturing the image processing and applying the machine learning, they predict the going to happen on the fall or what is the activities of the human. I am combining the both sensor data as well as using the heartbeat and image also I am capturing, and my algorithm detect based on the pressure activities, person is walking or stair gauge or running or going to fall, like that, my algorithm detect. If identify the going to happen in the fall, they immediately send the one trigger to the airbag system. The airbag system we can wear based on the person. Aged person means we have to wear in the keep. If any complicated task, construction like that, we have to wear the different type of the air cap. We have to select the air cap based on the work or the human age related, like that. My system here, our objective is my system produce the trigger signal to the air cap at a correct time. Okay, any research paper, the correct send the correct system of the air cap is manual is there or only based on the sensor is there. Here, whatever the previous, the last month activities, we will store in the cloud. Okay, here the many machine learning algorithm is there. Here I am using the SVM support vector. The reason is I will explain next slide. Here it is predict the accurate data at the correct time to trigger the airbag. So we can avoid the any injury happen in the future. Okay, first detect the sensor data. Whatever the flow, I will explain in the flow chart. Okay, first when we start our system, first detect the both leg pressure, right leg and left leg, as well as the heart pulse also. Okay, pulse we can measure from the heart or nose also we can measure. But here I am using the 3 type of sensor, 2 pressure sensor, 1 heartbeat sensor, and for sounding purpose and use the some other mic also. Sometime before going to fall, we are making some sound also, that also we can detect. Okay, from that observe the sensor data, we can identify if falls going to happen or not. Okay, this is my one of method. Yes, sir.
Sorry to, you have 2 more minutes to finish the presentation.
Okay, sir. Okay.
We have to finish on time because we have 10 more presentation after this.
Okay, I will make this. Okay, send the trigger signal to the air cap system, then make call to the hospital and particular guardian also. Actually, here many system using the GSM model GPS for making the call. By reduce the cost, I am using here some software tool like the Dulio and Delagram like that for reduce the cost of the system. Okay, then here AVM machine learning algorithm produce the report based on the fast history. Okay, it's already I explained, so this is enough for understanding our system. Okay, here now consider it is a leg 1, leg 2, both stable, both are having the same pressure means the person is standing. The continuous change means the person we can walk. The fast change of the both leg pressure change means it's a running. One is the high pressure, another is the very low pressure, like that means my algorithm detect the person is the upstairs going staircase. Not touch the both means the person is sitting. Not touch but heartbeat high means the fall going to happen, like that we can identify. Okay, this is my prediction algorithm. Okay, here in market, my hope is the implementing this pressure sensor and implementing that machine learning algorithm only. Our role not design a scope of designing the pressure sensor. The reason is this pressure sensor already available. It both upper layer and lower layer both having the pressure sensitive material component. When the person press, it will sends the data where it is pressed here bottom or middle or top of the flow also it will send the data to the controller. Okay, this is the specification. Here it will allow the 100 flow also. It is a fast response time 1 millisecond. Okay, like
last
that.
30 seconds for the wrapping up. Last 30 seconds for you.
Yes, sir.
Last 30 seconds to finish the presentation.
Okay, sir, like that you walk, stare, and sit and fall. Here our aim is when the pressure sensor detect it's going to fall means we have to release that air pack compressor. Here compressor that contain the CO2 cylinder case. When that our trigger sent to here, it is a to relay. It is the unlock. Unlock means it's immediately it fill the CO2 case and it detect the it predict the fall detection. Okay, here why I am using the fall IoT specification means it automatically directly connect to the cloud. No need to write any additional mechanism required for upload the data in the cloud. Okay, so I'm using the pressure sensor for identifying the human activities and the air cap for bold IoT send the signal to open the airbag. Why I used the fold IoT means it's automatically connect to the cloud and it's a fast response. Okay, here I am implementing using the software. Actually, the system already available in last 5 years, but they're using the GSM and GPS for sending the SMS.
Sorry, Professor Balamurgan, I think we need to stop here.
Okay.
Because we are exceeding time, sir, please.
1 minute I will complete. This is the proposed system, sir.
Sir, we don't have a minute. I think we should get for the questions. A lot of pressure from the organizers, sir, please.
Okay, sir. Thank you, sir. Thank you, sir. Here it is a received SMS, sir. When the dark happen, it is a received SMS.
Thank you, sir.
Fall detection.
I'm so really sorry to interrupt you, but we need to follow a timetable. Yeah.
Okay. I start.
Sir, my a basic question I have before Padmanabhan sir, starts. I have seen a couple of inventions from Hong Kong University. In this regard, they have a better system I have seen here. they have this pole sensing system, which also triggers a helmet sort of helmet-shaped airbag.
Yes, sir. Yes, sir. Yes, sir.
And that is majorly designed for cyclists,
Yes,
bicyclists,
yes, sir.
not for elderlies. So would you be kind enough to tell us the difference between that device and yours?
Yes, sir. Here, actually, my system important point is reduce the cost. Here, I am using the software tool to send the SMS. That only, sir. It is a very fast. It is a global wise. We can send SMS. Actually, there
No,
in
no.
previously.
I just am very curious. So, if you need immediate support, why do we need an SMS immediately?
SMS sent to both hospital as well as guardian person for take care of.
But
Anyway,
your device has already saved the person, right?
Saved, but not anyway. After some time, the person not to normal means became a normal position. After airbag also, the person due to some anything happened due to aged person back to normal position. Our system send SMS, not immediately send SMS. Immediately it trigger the air cap. After the person not back to normal position, both stand pressure get the any signal means after 5 minutes immediately send the SMS. Like that I designed. Anyway, we have to consider precaution also.
Over to Professor Padmanabhan.
Okay, thank you.
Thank you.
I just have one thing, like you must be, I think, injury specific and then location specific. This is just one location specific invention. What are your plans for something that can totally prevent or say detect or alarm suitably, a complete wearable IoT stuff, which need not be kind of, just airbag based or say any other app based or any other specific component based.
Yes, sir. Here my contribution is setting the IoT setup, but air cap we have to select based on our requirement. Suppose construction work we have to select complete like that. Any building or top level we are working means we have to complete air cap we have to select. Already I told the designing a pressure sensor and designing a air cap is not my scope. My scope is implementing and software integration. And trigger very fast. That is my proposed contributions. Okay. Anyway, selection of airbag and selection of the pressure sensor also the important tasks.
Okay, thank you.
Thank you so much, sir. The main contribution before going to fall detection, advanced trigger mechanism will generate by my coding using machine learning. This is my contributions.
Thank you, Dr. Balamurgan.
Thank you, sir.
Now I would like to invite next speaker, Mr. Shakti Jayasundar Rajshekhar. And the title of the talk is Thermochromic Labels, a game changer in COVID-19 testing.
Can you please unmute yourself? I think Sakti is, yeah, can you unmute yourself? Yeah, can you see your screen?
Shakti, just a reminder, you have 8 minutes for presentation and there will be 2-minute question and answer session. Yeah. Please try to finish the presentation within 8 minutes.
Yes, sir. Greetings to all. I'm Shakti Jayasundar Rajshekhar, MBBS student from Maruccio Institute of Medical Sciences and Research. The title of my work is Thermochromic Labels, a game changer in COVID-19 testing. So the coronavirus disease, the COVID-19. So it has been declared as a pandemic by the World Health Organization. So this pandemic has created a havoc in the socio-economic and the public health infrastructure of the world nations. So the majorly all the world nations have enforced strict lockdowns to reduce the impact of the disease transmission. So this has led to the closing of schools, colleges, and economic places. This has left millions unemployed, and this has made the economy to be in a worrisome position. So the key aim of the lockdown is to augment actually the lockdown doesn't cure the disease. It just passes the time period for the disease to attain its peak. So the key aim is that like we need to augment the public health infrastructure to effectively battle the pandemic and educate the people about the practice of hand hygiene, usage of masks and gloves, and social distancing. This is the key one. And aggressive testing to isolate the suspected cases. According to the WHO and the ICMR guidelines, the key strategy all over the world has been to test, cure, track, cure, and isolate. So the only with the vaccine being a distant vision, the only way we have is to practice social distancing and aggressive testing. So the COVID-19 testing is very important when we consider reopening. Right now we are having relaxations in the lockdowns. So when we need to reopen, we need to aggressively test people who again come into the environment. So in this case, the conventional testing procedure, which is done through the RT-PCR, which is the reverse transcriptase polymerase chain reaction, we need to do that. This test is of course considered the gold standard, but again this has its own repercussions. So this test requires a sample collected with the help of the nasopharyngeal or the oropharyngeal swab, which is the sample is collected from the respective parts of the pharynx, as you can see in the diagram, the nasopharynx and the oropharynx. So the key shortcomings of the RT-PCR is exorbitantly high-priced instruments, and so again these instruments need to be set up in a BSL standard lab, which is again not possible in all places. And even in India, we have only limited lab facilities. So the delayed test results, since the labs are not, the procedure itself requires a lot of time, and due to the logistical issues, it again takes around 2 to 5 days in maybe in remote places for the results to get announced. So there is also a possibility of the false outcomes. So the false outcomes, the reason is that these tests are simply based on the samples we take. So in the pre-analytical error, that is prior to the PCR process, in case of the sample not being properly taken or by untrained persons, it may lead to the false outcomes. There is the false positives and the false negatives. So the rapid antibody test kit, it's a potential alternate. So we can divide the virus detection diagnostic test into two. One is based on the virus itself, that is analyzing its genome, viral genome. That is through the RT-PCR method. We amplify it and we diagnose it. Another is through like how our body reacts to the incoming virus or the virus genome, which is the antigen. So our body produces antibodies like IgG and IgM in response to the viral antigen. So the key advantages of the rapid antibody kits is these are relatively much cheaper, well within 300 to 500, and they produce results within less than 30 minutes. So, but they are not being utilized in a wide scale in India and in many countries of the world, particularly in India. So this due to a doubt over its accuracy, and one of the major reasons of this decreased accuracy is that these kits may not be transported and handled under the recommended environmental conditions. So you can see a comparison of the RT-PCR and the rapid antibody test kit. So the PCR test requires sample from the nasopharyngeal and the oropharyngeal swab. That is antibody you can have with a blood sample or a serum sample. So function, it, as I said, it detects the presence of virus and measures the viral load, whereas this measures the antibodies. So testing facility, again, it requires sophisticated labs, BSL standard lab, and the rapid antibody, it requires point of care. And the test results, RT-PCR takes significant time, whereas rapid antibody test could give you within half an hour. It's due to its high accuracy, RT-PCR is still considered the gold standard, and is being advised by the ICMR to be taken as a proper reference thing. And antibody test kits again do have some false outcomes. So one of the major reasons is, as I said, lack of proper cold chain storage mechanisms and transportation systems. So I have proposed the COVID kit model. So this model contains a thermochromic label embedded on the kit. So this brings about a change on the color of the label when exposed to temperatures outside the recommended ranges. This helps to assess the potency of the viability or potency of the rapid antibody testing kit at the point of site use. This helps to ensure the authenticity of the test results. The key pros of this model is that it can be taken to the end user, like in gram panchayats, so that we could screen a large population and to find out the extent of infection spread within the population. So this is the model, proposed model. Here, this is the S is the sample well, in which you give a blood or serum samples. So actually, the sample contains the antigenic part of the recombinant SARS-CoV-2 virus, which is complex with colored components. So when we put our blood inside it, if it contains IgM or IgG antibodies, they react and it forms a colored product. So this this test is a kind of qualitative lateral flow immunochromatographic assay. So it migrates towards the upper cell. So in this, the control is always with the line to provide as a reference name. So the IgG and the IgM parts are immobilized with the human anti-IgM and anti-IgG components. So again, when they react, it produces a red line. So that this model doesn't require a complex analyzer kind of thing. So it can be visually confirmed, and this provides the results within less duration. And again, the top, it's the thermochromic label. The thermochromic label, it's being in use, and the inner square part should be brighter, like whiter than the surrounding circle, dark circle. So thermochromic labels, these can be apart from the usage of thermochromic labels in the rapid antibody kits, these can also be used on the sample containers, which have the which can be stuck over the containers which are being sent for the even the RT-PCR. So both ways, it can be also embedded on the rapid antibody test kit and on the sample container. So other applications of the thermochromic labels are used in wax and vial monitors and food and beverage labeling in medicines and in consumer goods. So, till now I had discussed about maintaining the viability or the potency of the kit from an administrative center or a hospital to the end user level. So now, from the manufacturing center to the hospitals, key hospitals, district hospitals kind of thing. So here,
you have around 30 seconds more.
Yes, sir. So here we are applying IOMT medical things. This is the paper we have referred. I'm working with Dr. Nandakumar from VIT University and Professor Baralakshmi from Anna University. We are planning to implement it on a large scale. So these are the results, as I have said. So these two are in a position where we can use, and bottom two, if the result is so, we can't use it. So conclusion, with the proposed model, this helps in identifying the viability of the test kits, which prevents the false results of the test. And with employing this, you can confirm the authenticity of the test, and which reduces the testing time and could be employed for large-scale testing. Actually, it's large-scale screening. You can screen large-scale population with this model. These are the references. Thank you.
Okay, thank you. Now, I would request Dr. Padmanabhan to ask a few questions.
Okay, this thermochromic table label thing is a very nice idea. Now, can you explain a bit on the mechanism with which it improves the consistency from 97-98% to almost, being perfect?
Basically, this label contains chemical compounds which, on principles like Bragg's diffraction, when it gets exposed to temperatures, then we have compounds like cholesterol, benzoate. When mixed in different proportions, you get to have a threshold temperature ranges of variety. So with different chemical compounds, we have different temperature ranges over which the rapid antibody test kit could act on.
Have you developed these labels yourself?
No, actually, these labels we are working on. We are working on it, and we have planned to file a patent with this.
No, you could have shown, in case you have developed some, you could have shown some photographs or.
No, we have not yet fully developed it. We are working on the chemical part.
Just an idea. I hope that's begun to work.
We are working on it, sir. Actually, it has, we have worked on an ICMR project. We have got it. The project has been approved, and we are working on it, sir.
Okay, thank you.
Thank you, sir.
I just want some bit of a specific knowledge. Now, normally an antibody kits are transported through refrigeration only,
Yes,
and subtle temperature changes, meaning 10 degree, if they are sustainedly kept in somewhere 37 degree or 40 degree, that can damage the antibody activity.
Yes.
But point is that, do you have any efficient thermochromic levels to detect that subtle changes? We know we have a lot of thermochromic systems which can detect very high temperature, like 50 degree jump, 60, 70, 100 degree jumps, they can recognize. But when we are discussing about 10 degree, 20 degree, do you have anything? Can you give an example of a thermochromic level? Which can...
Yes. Actually, the thing is, commercially available models range from 10 to 25 degrees. That's the recommended range they specify. Actually, different cholesterol products like cholesterol benzoate, cholesterol nonoate, and mixing those different compounds, we can, as you said, we can aim at a better detection or even subtle changes. And we are working on the effective combination right now, sir.
Good.
Thank you, Mr. Shakti, for the presentation. Now, I would like to invite Mr. Ramesh Yarnagula for the next talk. The title of the talk is Role of Big Data Applications in COVID-19 Studies. Mr. Ramesh Yarnagula. Mr. Ramesh, are you there? Okay. It seems he is not present in the meeting today. So we'll move to the next talk. The speaker of the next talk is Dr. V. Vetrivellan, and the title of the talk is Synthesis Spectral Hirschfeld Surface Analysis, DFT Calculation and Molecular Docking Studies on Dioxol Derivative as Potential Antibacterial Inhibitor. Dr. V. Vetrivellan. Dr. V. Vetrivellan, are you present in the meeting?
I don't think he is available.
I've just received message from the organizers that Dr. Vetrivellan is also absent. It's not present.
We can call the next one.
Yeah, I'll move to the next talk by Dr. K.S. Kiran. Dr. K.S. Kiran, are you present? Just first want to know that. Next is also absent. That's what I got a message. Dr. Bala Subramani. Dr. Bala Subramani, GL. Okay, so Dr. Bala Subramani, GL is also absent. Then the next talk is by Dr. Vandana Yadav. Dr. Vandana Yadav. Yeah, it seems Dr. Vandana Yadav is present. Yeah. So welcome, Dr. Vandana. The title of the talk is Role of Biopolymeric Filaments in Drug Delivery, a Microscopic View in Understanding of Their Inbuilt Dynamics.
Yeah, okay. Thank you.
Welcome. So
let me share my screen first. Yeah. It's there. Yeah, are you able to see the screen?
Yes, ma'am. Yes.
Okay. Yeah, thank you. So firstly, I like to thank the organizer to give me the opportunity here. So let me start from here. So I'm going to discuss the role of biopolymeric filaments in drug delivery. These biopolymeric filaments takes active part in various kind of mechanism like the drug delivery in the specific location in the cells. So let me go to the motivation part. So the motivation here is a twofold motivation. Firstly, I will talk about the fibers, which are mainly known as the biopolymers, how the intrinsic dynamics behave. Okay, and next I will show that how the this microscopic behavior of filaments going to affect the mechanical properties of the cells. So this filament dynamics basically is also regulated by the parameters, and these parameters are very much controlled by the presence of the barriers, which are basically the cell membranes and cell periphery. So now let's go for this to understand what kind of dynamics these filaments do. So firstly, I am going to show you the cell motility diagram, where you can see these red line structures are trying to push the cell periphery or the cell membrane to move further. So in this way, the cell translocates its position from one position to another. The another process where this filaments take active part is the cell division. So if you see in this cell division process, how these small threads are there, which are trying to pushing the nucleus into daughter cells. So that's the way cell divides into daughter cells. And the third very important mechanism which they perform is the cell transportation, where you can see these filaments are behaving like the roads or the transport tracks for the motor protein to deliver these vessels, which is shown in this circle, where it can be drug, it can be plasmons, it can be vessels, it can be anything which is needed to particular location of the cells. So now the question comes, like, why the filaments are so important, since they are taking active part in these kind of mechanisms, what the special property they exhibit. So let me show you this figure 4, which you can see this is a schematic diagram for the filament structure. Basically, this is the microtubule structures which are formed, as I told, these are the biopolymers. They are formed by the monomeric units known as the GTP bound tubulins. And the GTP bound tubulins, which are the blue circles, they come at the end of the polymer's end. And in this way, the polymerization happens. But in experiments, it is found that once the polymerization is persisting phase, suddenly there is an abrupt transition from polymerization to depolymerization, which you can see in this figure, and which they have studied through the analysis of the length fluctuation of these filaments, where you can see in the figure 5 that how the length of the filament is fluctuating, and there is a rare abrupt transition from the polymerization phase to depolymerization phase, which is known as the catastrophe. And the vice versa mechanism is also found, which is known as a rescue. So now the question comes, like, why these catastrophe and rescues are very much important? Because these are important because they are taking part in these cellular mechanisms, which are controlled by these kinds of abrupt transition, which are the catastrophe and the rescue. So the next thing the people have studied about, like, what are the other factors which are triggering the catastrophe mechanism. So there is an experiment has been performed in 2003 by doctorants lab, where they have seen that these microtubules are growing, and when they encounter the obstacles, they trigger the catastrophe to happen more frequently. So that's what they have studied by their data, by experimental data. They found out that the catastrophe rate is continuously increasing if the force applied on the filament growth is increasing. So this experimental model has given enough motivation to us to study this system theoretically. And some of the interesting questions we want to ask through this theoretical model. First, that how the force is going to affect the microtubule dynamics, like, for example, the catastrophe transition, which I talked in the earlier slide. And instead of having a single filament, if you have a multiple filaments, then how the barrier or the membrane is going to affect these dynamics. So let's go to this theoretical model here. So this is a completely theoretical model where I have assumed the filament to be a one-dimensional discrete polymers, and there is a force barriers where we applying of opposing force, which is opposing the growth of the filaments. And these three dynamics is also happening, which is a polymerization, depolymerization, and the hydrolysis. Then from the theoretical studies, we found out that this catastrophe rate, which I'm showing through the diagram 2, that this catastrophe rate is increasing very well with the force. But when the force is very high, the strength of the force is very high, then it started saturating near this point. So, and this result we have verified from the experimental results very well. Now the second motivation which we have raised in the previous slide, that if instead of having a single filament, because once you start the theory part, you take a more simplistic models. So now what I have done, I have put another filament, which is shown here, which is also sharing the common wall. Now we want to understand how these two filaments are behaving, this common wall, and how the load is distributed among the filaments. So we have characterized the parameter eta, which tells me that what kind of sharing it is. If neta is equal to 0.5, then there is no load sharing. That means either one of the filament is going to bear the whole load. And if eta is equal to 1, that means it's the equal load sharing. From the mean field approximation, we found out that that for some certain mechanisms, this eta is always one. Eta is always 1. That means there is an equal load sharing. That's what we are getting from the simulation results. These are my simulation results. So this part basically tells about the intrinsic dynamics of the filaments. Now we are going to apply this filament dynamics in a bigger picture, where we can tell about the mechanical properties of the cells using the stochastic property of these filaments. So in this paper, it's found that in the different cell conditions, the rate parameters through which this microtubule dynamics occurs inside the cells are going to be affected by in the different cell conditions. For example, in the normal cell, if you see this polymerization rate, basically this Vg and Vs are the polymerization and the depolymerization rate, and R plus minus and R minus plus are the catastrophe and the rescue rate. So in the normal cells, these numbers are drastically changing when it is a cancerous cell. And once they are drug treated by this sulforaphane drug, then these parameters are changed. Using these parameters, I have simulated the system of starting like 1,000 filaments, and then see that how this number of filaments get altered with different cell conditions. Why we have done it? Because this number of fibers are going to help in predicting the cell mechanical property. That's what I'm going to show here. If you see, this is a micromechanical approach which is generally used in cellular mechanics, and using this technique, we are able to calculate this stiffness tensors. Okay, so this formula is basically, which is shown here, is a relationship between the stress and the strain, and this is a standard 12th book thing, is like mechanical stress is related to the strain by this constant, and this constant is nothing else, is the modulus of the system. So by using the Mori-Tanaka method, we are able to calculate the stress tensors, this stiffness tensors, and it turns out to be the plot, this plot which tells me the shear modulus of the cells in the different cell conditions. So now the idea is, like, if till now we have taken a very simple system where the filaments are randomly distributed, we want to extend this model to let's say if the filaments are completely aligned horizontally or vertically, then what will be the cell mechanical properties? So that's what we have understood through this study. Now let me summarize here that firstly we have understood the stochastic dynamics of the fibers, and then we have seen that how this dynamics is going to be affected by the membranes. Then using this property, we have tried to investigate the mechanical properties of the cell in the different cell conditions. So yeah, thank you for listening me. Sorry. Hello.
It's a good work. Congratulations, Dr. Yadav. It's an excellent work. There are a couple of questions. I think I'll allow Padmanabhan sir to ask, and then I'll continue.
Okay, fine. Like I was a bit raring to go because micromechanics, my favorite subject.
Okay.
Yeah, please.
Thank you. So like Vandana, I just want to know, like in the fiber length, you said 0.8 without specific.
Yeah.
Microns, or I haven't known. Can you just go back to that magic slide? Maximum fiber 0.8.
Okay. It's actually it is a 0.8. Yes.
It is in microns, or?
It is in microns.
Microns.
Yeah.
So like Vg, Vs, R plus minus, R minus plus. They are all in microns, right?
All are these in microns.
All the dimensions are in microns.
Yes, yes, yes.
Now, like when you apply micromechanics, there are two conditions.
Yeah.
There's something called a there's something called an aspect ratio for every fiber. I'm sure.
Okay. Yeah. Are you talking about the this volume fraction thing?
No, not the volume fraction thing. The aspect ratio is actually the length divided by the diameter of any fiber.
Okay.
Now, geometry-wise, not mechanism-wise, geometry-wise, if L by D is less than 100, it's called a short fiber.
Okay.
Now, in your case, like your fibers are kind of they're very short, cylindrical or microtubule-like fibers.
Yeah.
Now, I think you must be careful when you apply micromechanics to short fibers or long fibers.
Okay.
There is a distinct delineation, mechanically or geometrically or both. It's better to do both.
Okay.
Some fibers behave like short fibers and some of them behave like long fibers, depending on the aspect ratio.
Okay.
And if it's too short a fiber, what happens is that it doesn't take the full load or the full stress that is possible for it.
Okay.
It needs a sufficient length in order to have zero free edge effects, at the same time reach its fullest efficiency of load bearing capacity, exhibiting maximum stress.
Okay.
So if you measure the shear modulus and strain for short fibers, where the aspect ratio is only 10 or 5 or 20 and so on, that would be entirely different.
Yes.
From the fibers with or microtubules with an aspect ratio of 100, 200, 300 and so on.
Yeah.
So like I'm sure you adapted Mori Tanaka, but
yeah.
Must be careful in understanding whether it's a short fiber or a long fiber.
A long fiber, okay. Yeah, that aspect actually I did not thought in that way, but I will try to incorporate. Yeah, sure. Thank you. Good suggestion.
It's not a solid cylindrical cross section. If it's only a tubular cross section, you must be doubly careful because it has got a dual interface.
Okay.
It's got a dual interface. Okay, and then you don't know the load distribution very well. Even for structural fibers that are, tubular and stuff, to be very honest.
Yeah, sure.
About solid fibers.
Okay.
And if it's a hollow microtubule, it's going to distribute a lot of load depending on the fiber bundle distribution. You do not know whether it's a hexagonal array or a square array or a random, sparsely distributed array or a kind of an agglomerated array and all that. So if you do all that and then do the study and then it will be great.
Yes, definitely. Thank you. Yeah, thank
you. Good presentation, Dr. Yadav.
Thank you.
For the same slide, I have a couple of questions, and I want to have overall, your summary out of some questions. The first question is, the drug you have used is 15 micro M. What is that?
See, it's the parameters which is completely published in this paper which I have cited here, and I did not have a detailing of like how they have how much concentration of the drug they have.
A drug concentration cannot be a 15 micrometer. Point is that
no, it's not. It's a molar
it
concentration.
Should be capital M.
Yeah, that should be my fault. Yeah, sure. So, it's a molar.
Yeah. That is all, and I just want to know that you have done theoretical calculations on things. Have you expected? Do you understand that overall cellular motion? Because the final output you're talking about, trying to explain the motion of a cell. So, and cells do have a very rigid cytoskeleton, which is made up of actin filaments.
Yes, these are having very high viscosity also.
Yeah. So. And plus, the membrane also play a very important role in that. Membrane fluidity. So, have you considered these parameters into your
actually,
model?
That's what I want to mention here. See, when I started this theoretical model, so as I told, like this is a very simpler model we started. Now, what we are going to do next, like we are going to change this force barrier, which is a completely a rigid barrier. We are going to introduce the safe fluctuation in this barrier by using the Langevin equations. Then it will be more realistic. That's what. Then we can see that how the we can really tell about the things like how the membrane is going to affect the other parameters. So that is the next step for us. Instead of having a rigid barrier, we are going to introduce the safe fluctuations in this barrier, which is more real to the plasma membranes or the cell boundaries, because all the time the shape of the cell is continuously changing because of the stress. So that's what we are going to incorporate in next work. Yeah.
Okay, good. Over to Professor Jiten. Thank you, Dr. Madana.
Thank you very much. Thank you.
Thank you, Dr. Vandana Yadav. Thank you, Dr. Padmanabhan and Devashish. We are running out of time, so we'll move to the next talk. Okay. Now, next talk is by Ms. Suja A. Alex. I hope Ms. Suja is present here. Yeah, she is present. The title of the talk is Building Online Classification Model for IoT Data. Ms. Suja Alex.
Dr. Vandana, can you please unshare your screen?
Dr. Vandana? Yeah. Ms. Suja A. Alex?
Dr. Suja A. Alex, can you please unmute yourself? I'm.
Okay, sir. Okay.
Yeah. Can you please turn on your video?
Hello, sir. Shall I share my presentation?
Yeah, please go ahead.
Good evening to everyone. I am Suja Alex from St. Xavier's Catholic College of Engineering. I am going to present my paper on the topic Building Online Classification Model for IoT Data. First of all, I would like to explain a little bit about traditional data management. Then I move on to that data stream concepts. So who will generate data actually in case of traditional database management system? We all know that in the traditional case, we only generate data, but it is not much high level. We will generate a few, that is required as per every day, whatever data we need, we will generate and we'll store in a table called database format. That is easy to manage in the traditional database management system. And data also generated in a fixed rate only, in a fixed volume, because every day we used to generate a minimum set of data only we used to generate. We can store in a disk. And this data is called persistent data because this data is not going to be changed every day. Once we store, it is a permanent data. So it's called persistent data and we store in a reliable storage disk. And whenever we want to update this data, we can easily do the help of queries. So using SQL queries, we can easily update the data already we stored in a disk. And one of the common machine learning approach uses a technique called as batch learning, because in the case of batch learning, we can take 100 data or 1000 data or 10,000 data stored in the disk, and we can apply some machine learning algorithms for analysis purpose. For example, retail data is an example of this traditional data or transaction data. So next I move on to that data stream concepts. So data stream concepts initially came with the help of the concept, with the help of technology search engines, the Google, Yahoo we are using. Nowadays we are going to search a lot of whatever the doubt we are having. We used to apply a query in a search engine, and also smartphones generate a lot of data, social networks and query streams will generate, the search engines generates queries and a lot of clicks we do. So these are all the examples of streams. So with these concepts, the data stream concepts arise. And this data stream is an advancement in hardware technology, because nowadays all the hardware elements going to talk each other with the help of these stream concepts. Best example is of IoT. The IoT sensors, all the sensors communicate by sending messages. So those messages are called as live streams or data streams. And this can be of automated one, and it's coming in a very fast. So it's a rapid data, and it's temporarily ordered one. So if we want to store this type of data, it's very difficult to store this data in a permanent space, and it's a huge volume, and it's a nature will be of infinite data streams, and it's coming very fastly on the fly. It's very difficult to handle. This is what the situation of a data stream. And so one of these things we can do is within a one pass, we can have a solution. Within a one pass, we can apply some analysis or machine learning algorithm over the on-the-fly data to analyze about its pattern. And this, but if you apply some random techniques, it's also highly expensive one. It takes more time. We may not get the accurate results. We get to only the approximate solution. So we can use single scanning algorithms. So this type of single pass algorithm or single scan algorithm is suitable for this stream area. But with the help of the limited computing abilities and storage abilities, it's very hard to do this type of algorithms. Some of the examples of data streams are data comes from electric power grids, network traffic data, this telephone conversation data, ATM transaction data, all the web search engines searches keywords, then sensors data, time series data, or the real-time examples of data stream. Some of the real-time functionalities of data streams we can see in the case of a smart patient care, smart car, smart home, smart city. All these IoT entire networks will works based on these data stream concepts. Next, I would like to show that traditional versus stream processing concept. In the traditional, as I said, it's fully of persistent data, but in the case of stream, we have a transient data. Transient in the sense that is the stream pattern is keep on changing. It won't be the same, and it will be of a huge. We cannot expect its rate, its speed, everything. And traditional processing, we can use one-time query to search, or we can access, or we can retrieve data from a database. But in case of stream processing, we have to apply some continuous queries. And traditional processing, we can have some random access technique. But stream, it's if you apply random technique, we get some data, but we may not get accurate one. So we have to go for sequential approach. Then traditional processing follows multiple pass. Also, we can have, that is multiple pass means a single algorithm can be iterated for multiple times to get a more accurate result. But in the stream processing, we cannot apply, we cannot spend much time iterate over a particular piece of data. It's really hard. So we have to apply some single pass data, single pass algorithm only we have to apply. Then similarly for this traditional case, we have unlimited processing time. We can have unlimited memory space, and we get the accurate result because of the iterative algorithm. But in the case of stream processing, we can apply only single pass scanning algorithm, then restrict within a short time and within a short memory usage, we have to complete that process and get the approximate result only. Next, I would like to share the difficulties in stream processing. First one is amount of memory, and time to process the data is also difficult. That is, it takes much. That is, within a short time, we have to process the entire large data. Next, time to answer also, we have to, within a short response time, we get the answer from the streams. So what we can do, some of the solutions are, we are not going to store anywhere. We are not going to store the actual data, and we are going to store only the summary. Summary is called synopsis information, or we can say it's a statistics. So from the on-the-fly data, I'm going to extract only the statistics or the properties that I'm going to store in my personal disk. So these thing, I want some algorithms to process these large streams and I want to convert these entire streams into sublinear fashion. So I can reduce the space into half. Some of the summarization techniques are data reduction technique and sliding window approach. Data reduction techniques include sampling, synopsis and histograms and wavelets. We'll see one by one. First one is, I would like to say about sampling. Sampling is an important concept in statistics. So in sampling, we have the term population and the sample. The population is nothing but collection of different data elements. But out of this population, I'm going to extract only few data called as sample. But the sample should reflect its entire characteristics of the target population. That is the major characteristic of a sample. So with this concept of statistics, we can apply this sampling concept over the streams. So we have to select the subset of data, and for a particular time interval, we can select a few data. So that whereby we can reduce this time, and we can have process our data. But this representative sample must be most appropriate and should convey more information about our entire parent source data. So one of the technique is random sampling. So the random sampling is a very good approach, but here the case is we are going to randomly pick few samples from a large entire infinite data stream. But picking a random data sometimes may not be accurate, means its total process will be collapsed. So here we maintain a sample of size k, means we are going to store particular size of data over a storage space or buffer called reservoir. If you store a particular piece of data in your reservoir called, then it is called, the method is called reservoir sampling algorithm. Then we have min-wise sampling algorithm. Here for a particular range 0 to 1, for example, minimum value will be chosen. So this also we can follow. Next one is the load shedding approach. It's also one of the sampling approach. It controls the congestion problem in your streams, and also it for every fraction of second it deletes the few data from this large stream. Then one more thing is the probability of detecting changes and anomalies also is difficult. When we use sampling approach, definitely we don't know that when the change occurs, when the problem occurs, and what anomaly happens is very difficult to find. The second approach is synopsis and histogram. It is also one of the approach for summarizing our huge data. So here this synopsis means there is a frequency distribution of all the elements of a stream. That is how many times a particular element occurs, that we can store the frequency or the count in a graph called as histogram. So this one more thing is sketch. Sketch also a kind of synopsis. That is sketch also, it's like a data structure where we can store its count of particular data elements, its repeatedness that will be maintained in a separate structure called as sketch. Next, we can have an approach called as window-based approaches. So window-based approach is the way for capturing a data. So because infinite data stream is, we cannot apply the algorithm to over this long data stream. What I'm going to do is we can have a window concept. So particular window size, for example, 5 means we can capture only the 5 data from this large data stream. So we have an approach called a sliding window concept. So the sliding window will be a fixed size one. So when we obtain first 10 elements, then we can process the 10 element. Next, when the data is coming, the last element will be deleted from this window, and we can insert the new data. So in that way it works. The landmark window means it's another approach, window-based approach. So here we have to specify the particular time. For example, 5 to 10 minutes. That is within this particular time, I can capture data from a stream. Then based on this, the new data will be added to this existing landmark window. Next one is timestamp based window. So here also the window size is fixed, but each element is added with some time value. So that is the data with the that is most old data will be deleted from this window. This is an example of sliding window approach. Okay, next I want to data stream mining concept. So data stream mining comes under machine learning. That is the machine learning normally suitable for a small data set, or for we can also nowadays we are applying this over this big data also we are going to apply, but it uses data mining concepts. So stream mining we can apply over the large data that is continuously coming. So over this continuous data I'm going to extract the knowledge and trends, correlations, everything we can extract. So it's a summarization of stream. And there are 3 dimensional problem occurs. There is based on time, based on memory, and based on accuracy, we are going to mine our data. So some more challenges are huge volume of data. Online data is there only. So here one major problem is their concept drift or concept change. And we may have the classification problem. We may have either partially labeled data or delayed labeled data may also present the stream. So finding the exact answer and or approximate answer is also a very trade-off in case of stream mining. And both online mining and offline analysis can be done in the case of stream mining. So what is concept drift means? That is in the case of stream, real-time data stream, when we see that the stream can be of comes in its pattern will be of initially of a particular density, probable density. When it goes on later on, its density may change to from, for example, normal distribution to some other distribution on a later time. So this type of changing of distribution pattern is called as concept drift. It's a major problem in streams. So it can be detected properly with the help of some algorithms. And so this type of traditional analytic process, if we follow for processing our data, we may face accuracy problems, and we may face it's very difficult to take a correct decision at the right time. So some of the data stream mining tasks are classification, clustering, regression, and frequent item mining. I'm going to focus on clustering here, because clustering is one of the approach for grouping of all the elements as per data mining concepts. Clustering is process of grouping of similar elements. The same data clustering concept we are going to apply to data streams also, because when data stream comes fastly, we can capture the help of a few data. We can capture the help of window-based approach. Then within a particular window, he becomes set of data where we can apply some clustering algorithms. So these clusters algorithm will form set of clusters. So those clusters will be further useful for analysis purpose. So here it stores, each cluster stores a cluster feature, or we can call a micro cluster. So it's a compact representation of data points. Simply it stores the statistics. So normally this type of micro clustering concept will be useful for online data stream gathering purpose. There is online data analysis purpose. We can use this micro cluster concept. Then once this clusters will be finalized, then we can go for macro cluster in the offline phase. Finally, we can get a big cluster by combining all the micro clusters. So actually this micro cluster, it stores various details like number of elements in each cluster, linear sum of elements, sum of squared elements. So those are the various parameters will be stored in this micro cluster. So this micro cluster can be used for classification purpose. So my proposed system is I am going to use this sliding window approach and micro clustering approach over IoT data. Then I'm going to perform the classification with the help of KNN classification algorithm. This is one approach. The another approach, I am also having a plan of
You have just 1 more minute. Already 10 minutes are over.
Okay, sir. So
try to finish.
Okay, sir. Sure, sir. So the sliding window, second approach I'm having for experimental purpose, I have another option. There is a sliding window. When I collect a few data, I have to convert this continuous into binary. Then I have to apply discrete behavior transform. Then gray level co-occurrence matrix. Finally, I can have a KNN classification. These are my two approaches that I'm going to do for experimentation. So for this, I'm going to use this experiment purpose. I'm going to use MOA, Massive Online Analysis Tool. It's related to Veka tool. So the coding is fully based on Java. With this, we can do this. Thank you.
Thank you, Dr. Suja. Now I request Dr. Padmanabhan to have one quick question, sir.
Yeah. Like, I too am not expert in IoT data or KNN, but I'm just curious to know what would be the applications of the proposed model. What would be the main applications of the proposed model, and then where you plan to implement it?
So actually, I'm planning for applying to over Twitter data, tweets. We can classify the tweets with the help of this approach. Actually, I'm planning for IoT data. So in the future, we can also apply for Twitter also. Twitter, the tweets, we can get many tweets. Which one is a good one? Which one is a positive tweet? Which one is negative tweet or neutral? This type of classification we can do with the help of this approach.
All right.
Just
no question from my side. Thank you.
No question. I would like to thank Dr. Suja for this nice presentation. Okay.
Thank
you. I want to check whether other speakers are present in the meeting or not. Dr. Raj Kanni Polypandian. Dr. Raj Kanni Polypandian. Dr. Dipesh Kumar Thakur.
Professor, since I am Rajan Babu, since it is an online platform, they may join at the exact as per his time.
Okay.
Yeah, we have to wait till the last student start time.
Sure.
Am I correct?
Okay, sir.
Yes.
So I will check the.
Yeah, suppose the last student is 7:15 means, so he may join at exactly at that time.
Okay, noted, sir. Noted.
Yeah, we cannot close. We cannot. If it is a in-person conference, we can find the person nobody available. We can wind up. This is based on his time availability. He will come and join. Let us wait for some time.
Dr. Pula Pandian probably has joined now.
I will call you. Sir, I will call upon other speakers who were not.
Yeah. If he's available, we can pre-pone the session. That is not a mistake. And if the person is coming late, we can accommodate at the end. No problem.
Yes, sir.
That we can do, but we cannot wind up. No, three student absent. We cannot wind up. Am I correct?
Yes.
Yeah. Thank you.
Yes. So, it seems Mr. Ramesh Yarnagula had joined the meeting.
Yes, sir. Can you hear, sir?
Okay. Yeah, I can hear you. Sir, can you please share your screen?
Yeah, sir.
And also the video, please.
Yeah. You have already joined, I guess. Please do
somebody is sharing, sir.
Conference, sir. Oral session, good. Sir.
Ramesh, sir, can you please unshare the screen?
Sir, I'm unable to share actually. Somebody is sharing.
Ramesh, sir. Sorry, Rajan Babu, sir.
Yes. I'm checking, sir. I'm checking. Ankur is sharing.
No, I am not sharing.
Okay.
Now it is fine.
Mr. Ramesh can share that screen now.
Right, sir.
Ramesh, okay.
Hey.
Yeah.
Is it okay, sir? It's visible?
Yes, you switch on your video also.
Yeah. Sir, video, it doesn't support actually. Sir. Hello.
Yes.
Yeah. So, thank you, sir. Thank you very much given the opportunity to present my paper. And today my paper topic, role of big data application for COVID-19 pandemic, a study. Basically, sir, this the study was conducted during this period. We have collected the literature, whatever the literature published on COVID-19, we have collected. On that huge literature on big data application for pandemic and COVID-19 pandemic have found. So on the looking on this literature, I have prepared the work, this present work. I'll just brief about what is the role of this big data application, how it can be and how it is mitigating our this pandemic, the COVID pandemic, and then how it is helping, how it helped to in each sector actually. So in that regard, as we know that this presently the country in India has a huge population and increasing repeatedly that infected people are day by day it's getting very increasing very highly. So in that, as now we're more than 2 billion across world people are infected, and more than 8 lakhs people were have died in this. So it's very pathetic situation. And looking into this situation and this corona disease have dynamically changing its nature, and the data has potentially the data of this the infected data is so it's potentially it's increasing. So somewhere it need to be that today's technologies are playing very bigger role, especially the big data has plays very vital role. So in this it's having a many advantages on this big data, and I'll just present over. Before that, how this pandemic given opportunities. Also, I'll just give a brief idea on this. This COVID-19 opportunities, it's completely given a transferred digital transformation has highly impacted on this, as well as the social transformation also, and and also this maximum the maximum activity, the productions is converting into the digital online mode. And the same time, we all know the work culture is completely changed. Now the work from home is almost all sector, especially government sector also has predominantly as now so forcing to do this work from home. At the same time, this due to this COVID-19, somewhere it is highly reduced the air areas, and then the telepathies and this consultation in the hospitals and all so more is increasing very highly. So whereas earlier it's very less. At the same time, education and altogether it's a very game changer in in the competition also. So these are the opportunities have come during this COVID-19. So but how the big data is playing a greater role. What is the big data actually? The big data has it's the concept has come at around 2000, at the early 2000, what the literature shows. So and then after it's progressively for the last 10 years is very progressively has it shows its performance. At the same time, these are due to this, especially this the pandemic position situation. It's given a very vital role and given a very helpful. And this big data has as a nature of the voluminous and velocity and veracity and variety. So these are the composition of this where the big data can be called. So these 4 volumes supposed to be fitted, and that is which has been given by the Dux Lancy is the author who has suggested this. So these are the models also. There are various models are applied in the this big data. So descriptive analytics. So the descriptive analytics model is what happened in the big data. In that cases the descriptive analysis uses. At the same time, diagnostic analytics, where why it is why did it happen in that particular situation, the diagnostic analysis will uses. And where the what will happen is the predictive analysis. The predictive analysis, very diagnostic analysis, descriptive, diagnostic, and predictive plays very vital role existing the COVID-19 pandemic situation. So these are the modalities where within the big data characteristics, and there's many applications also. This there's some technical applications where this MongoDB's database is very useful in this. It provides an operational capabilities for interactive and real-time workloads. Whereas in similarly NoSQL, Hadoop, Hive, these are all the architectures where it applies for the in order to be the analysis as well as collecting the data and all the stories of the data. So another tool is MapReduces, which provides a very analytical capabilities and very highly popular in this existing time, this pandemic time. So basically, this the big data is very useful in order to be increase and optimize operational efficiency, and the cost also very reduced. Whereas the similar data, if we wanted to collect in earlier in traditional times, so it's a huge expenses to took place. Now it's completely it's reduced. Through this big data as reduces the cost also very drastically reduced. And at the same time, and altogether the risk point of view, the risk analysis very the crucial role, the very vital role this big data plays, and in the form of risk analysis. So we these are some of the areas which we very significant role this big data plays, especially in this whereas the wherever the cases highly infected cases in that aspect, the big data plays very vital role. It has a capability of the big data has capability of a huge storing capacity. Through that through that feature, so it gives an analysis, a very predictive analysis. It gives a predictive analysis and gives a kind of solution.
Sorry to interrupt, sir. You have 1 minute left.
Yeah, concern is similarly there's information of the virus at the early stage, and very it's also supports its capability to give an it gives an early stage. The big data helps in gives an information at very early stage. The same thing and during the lockdown, what kind of the movements of the people, the more it supports the tracking and monitor and all activities. At the same time, this the detecting the few symptoms of these COVID-19 activities also. It's a very vital role. This big data has a very vital role in all aspects of this mentioned aspect, and giving a very fruitful results. As such, in my the study which I have found, the literature and all, so it gives an it has big data has a very potential to store a massive amount of information. At the same time, it gives a very very fast information. It provides a very fast information so that we can prepare risk for the
Mr. Ramesh, please finish. Please conclude.
Yeah, to avoid the risk, and in that level, I'm just concluding. This is very useful in, especially in healthcare organization, and making it taking a decision making, and the big data plays a very, very vital role. This is my work, sir.
Thank you, Mr. Ramesh. I would request Professor Padmanabhan if he has any questions.
I guess, like, I'm curious to know what exactly is your contribution in this, or is it just a sum up of existing literature?
Sir, basically, sir, this I wanted to say that I wanted to emphasize that this work has the big data plays very vital role. Where it can it can apply in every the situation, this kind of situation, and the people can adapt this technology. The concerned agencies can adapt this technology, can reduce the risk factors.
I believe.
Thank you.
I believe Dr. Vetrivelan is with us now. I would request Mr. Ramesh to share his screen.
Dr. Devasis, can we stick with the time if the participant is in the time at 7?
Sure.
In
the chat box now, one student is asking a passcode and ID. So like that, he may come later.
Okay, but I think Vetrivelan sir, I can see him in the participant list. I mean, now. Ankur, your voice is it's not coming from Mr. Ankur. Yeah, I could see his connection isn't working. Then we have Dr. K.S. Kiran also online, I guess, if we can have him. I can see him in the participant list.
Actually, the participant at 7 is already available, so I will give the time to him. If the rest time is available, then we will move to the next participants who were absent at their time.
Yeah, Dr. Bhaskar, I think Dr. K.S. Kiran just has unmuted or shown his video. Let's just see that if he's available. Dr. Kiran, yeah, you can unmute yourself. Are you ready with your presentation?
Yes, sir. Yes,
please,
sir.
Please share your screen. Thank you.
I'll share. Okay.
We are going to have Dr. K.S. Kiran, who is going to present on crystal and molecular docking studies of bisocyclohexylene diols with focal adhesion kinase inhibitors.
Can I start, sir? Can I start?
Yeah, please go ahead.
Yes.
You will have, just remember, you have 8 minutes. Try to wrap up before that. Thank you.
Okay, sir. Fine. My topic is crystal and molecular docking studies of bicyclohexyldiols with FAK as the inhibitor. Outline of my talk is introduction, material and methods, preparation of the ligand, preparation of the protein ligand interaction using autodock, binding site prediction, docking energy calculation, results and discussions, conclusions. Here I've taken this cyclohexyldiols is a newly synthesized drug compound. What is the peculiarity in that is, which is a plain molecule, non-planar molecule, which is having a peculiar property exactly at the C9 position in the hydrogen structure. That is one with dichlorobenzene as well as another with the dinitrophenyl exactly in the C9 position. This have a inhibiting characteristic feature of anti-cancerous as well as anti-tumor activity. Now, the crystallographic study of these molecules have a better insight to have the molecular packing as well as to have the design to a lead molecule to a better biological activities. And stabilizing this crystal structure to have a better insight to a drug design. And second part of the stability of the crystal structure is the docking studies. We to identify the receptor or the target to have the binding site prediction to have a rational approach for the drug design. This is my R-type diagram for the first with the 2-hydroxy-dimethyl dichlorobenzene exactly in the C9 position. This is the original structure we got from the experimental result, almost the same structure. It almost resembles the same. This is crystal data obtained from the compound, the monoclinic crystal system with the P2 upon N, with the final R values around 0.072. This is a packing diagram for the molecule with the bicyclohexydiols, with the shows about the how exactly the packing has been done with the CHO interaction. Carbon, hydrogen, oxygen interaction is there. You can see here with the CHO1. The second part is nothing but the molecular docking. It tells about their binding site prediction, and there are thousands of compounds are there to have the virtual screening. We do for the virtual screening to have a lead optimization. Later, we'll go for the chemical mechanism studies. This is a flow diagram for the molecular docking. Ligand is my synthesis, the compound, new compound. Receptor is my protein as a target. Protein with the ligand with the receptor is nothing but the docking studies, the binding site prediction. Later, the third stage, we are going for the future drug. Now, this is a target chosen for my molecule, that is a focal adhesion kinase is a target. It has been downloaded from the protein data bank directly. This is having a peculiar property that kinase have a cellular adhesion as well as the cell stick together with their surroundings, as well as the addition, migration, etc. This is this, we have used the docking software as a Autodock as well as the FlexX. We are compared with both the software, one with the Autodock software as well as the FlexX software. You can see that the newly synthesis cover exactly it has bind with the focal adhesion kinase, a target protein. It has been bind in the force formation. Same is compared with the FlexX also. You might have seen here the binding site, exactly the ligand has been bind with the newly synthesized drug. This has been force taken with the different direction to tell about their donor level as well as the acceptor level. This is to tell about the protein ligand interaction with the amino acid to study about the various interaction like van der Waals covalent or electrostatic interaction using the Discovery Studio software. These are the residues of the amino acids. This is my crystal structure. This tells about the 2D interaction using the molecular surface. Exactly, we are calling as a Lick plot residues. These are the residues of the amino acids. and this is my crystal structure. We'll call this a lick plot exactly in the molecular surface. These are the results obtained. We are taken from, we'll call it as a pose fitness from 1 to 10. Higher the negative value, the better affinity of the molecule. We obtained around minus 6.13, least around minus 4.33, with inhibition constant around 32.02. And these are the residues of the amino acids that are seen in the previous. Second part is the pose rank we used to take, that is called as a dot score. It is minus 10.62 is the highest one. The lowest one is minus 6.81 with RMSD value around 2.41. Lowest one is 4.38. These are the residues of the amino acids. Third part is the drug development, discovery and the development. These are the various stages we are involved in the drug delivery development. We have to identify the disease, we have to identify the target as a protein. Later, we'll go for the docking studies. Finally, for the final drug, we have to go for the clinical. This is challenging one, preclinical studies. Later, we will come for the human clinical trials also. That is, we are calling as in vitro as well as in silico AMD model. Later, we'll go thousands of compounds we have to virtually screen to a lead optimization to have the preclinical as well as the human clinical studies. Same the flow diagram as shown with the drug delivery, drug discovery and the development to identify the disease and the preclinical trials with the either animal or human, that is clinical trials. Formulation it will take another 1 or 2 years, and human clinical trials, finally with the FDA approval. What is the results means to understand what are the pharmaceutical data obtained to evaluate a better insight using the docking studies. Higher the negative value, the better affinity of the molecule. This binding site prediction confirms that effectively fit to the target of the protein. In this study, one with the dinitrochloro as well as dinitro with the binding energy obtained minus 6.42 with the inhibition constant around 19.68. Now further, it has been taken to animal trials as well as the human trials for the to study about their inhibiting character in vitro as well as in vivo studies. Conclusion: the intramolecular interaction between the ligand and protein was investigated. The bioactive compound shows as a potent inhibitor to the the FAK protein. The selected compound has been taken to a dark value to a wet laboratory, that is in vitro or in vivo, or to use it as a I wish to acknowledge the VGST. This is a funding project, the Vision Group of Science and Technology, Bangalore, for funding this project, and our director, Dr. Rai Prasad, Jain University, Bangalore. Thank you.
Thank you, Doctor. I would request Dr. Padmanabhan to ask.
How did you characterize these ligands and then these long molecular structures? What do you mean? Have you characterized them using certain specific techniques or any technique that applies to these kind of peptides or other kinds of macromolecules or molecules?
Sir, not going to characterize anything. Directly, we are taking from the chemistry, newly synthesized drug. Later, we'll go for the second with the crystallographic XRD studies. Afterwards, we'll come for the docking one, sir. Docking one.
Come for the
docking studies. Docking studies.
Oh, you did the X-ray crystallography.
Yes, sir. Yes, sir. Yes, sir.
Like low angle, small angle, or
what, sir? I didn't get.
Small angle, or what kind of X-ray crystallography? What was the target?
Single crystal. Single crystal. Yes, sir. Yes, sir.
Single crystal studies. Okay.
Yes, sir. Yes. Yes, sir.
Okay. Thank you.
Thank you, sir.
I have one question.
Yes, sir. Yes, sir.
So, what was the rationale behind selection of this bis cyclohexyl diol as an inhibitor?
That is from the literature survey, biological activities, mainly anti-cancerous and anti-tumor, sir. We are working on that mainly for the anti-cancerous. Because of that, we have chosen that bis cyclohexyl diols. It's a non-planar molecule. Only based on that.
Have you done any study with other inhibitors which are resembling with this bis cyclohexyl diol in structure? or say
Yes,
cyclohexane?
sir. It is there, sir. It is there. It is a family of that one NIP. We have taken two derivatives, exactly dichloro as well dinitro, sir. So many derivatives are there. We are trying with these two because we got the good result in these two derivatives. In the basic
So have you done? Okay. Have you done any GROMAX analysis or yeah? Have you done any GROMAX or NMDA analysis for this to check the structure?
GROMAX are not. No, sir. Dynamics are not. GROMAX are not done. Dynamics so far are not done.
Okay.
No, not done with that.
Thank you.
Thank you, Dr. Kiran.
Yes, sir. Thank you, sir.
Thanks for your excellent talk. I would now request Dr. Bala Subramani, GL, to talk on his topic, that is structure-based drug repurposing to inhibit the DNA gyrase of Mycobacterium tuberculosis. I'm sure he is joined with us. We had a chat also.
Sir, Mr. Mukesh Sutar. Professor. Professor Devish Mishra.
Yeah, Dr. Rajan.
One Mukesh Sutar is waiting in our group.
Professor Mukesh, I don't see his name in the list.
He's in our list. He's in this panel.
The list sent to us. Okay, fine. We can allow him, but
No, he is not here, sir.
Okay, then I will ask him to go to session 2.
In our panel, he is not here anyway.
Yes.
Hello, yes, sir. This is Bala Subramani here.
Yeah, please. I would request you to put your PC in presentation mode now.
Yes.
Share your screen. Yeah.
Yes, sure.
I would like to remind you that you have got 8 minutes.
Okay, sir. Okay. Good evening to all. I would like to thank the organizers for providing me the opportunity to present my work in this conference. So my research work, the work which I am going to present, which is entitled "Structure-based drug repurposing to target and inhibit the DNA gyrase of Mycobacterium tuberculosis." And so basically, drug repurposing, it is finding out drug repurposing or repositioning allows pre-existing drugs to use for the new indication that were not their initial target. There are basically two approaches for drug repurposing: discovering a new target for the known drug, or discovering the role of known target for the new indication. So in the current work, I have focused on identifying a new target for the already known drug from Mycobacterium tuberculosis. So these are the basic advantages for using a drug repurposing approach. And mainly the genome of Mycobacterium encodes for more than 4,000 proteins, which necessitates scrupulous selection of a drug target. So among these, the identification of new antibacterial targets, that is proteins which are DNA gyrase, which are mainly involved in DNA transcription process and further downstream processes, that is which makes it vibrant, which makes it more vibrant area of discovery. And the main function of the DNA gyrase is it negatively supercoils the DNA, which is a functional form of DNA, which is required for the further downstream applications for the bacteria to take place. And there are resistant mutations has been reported in DNA gyrase. Which are fluoroquinolone resistant mutations, which takes place in the gyrase A subunit. Basically, DNA gyrase is composed of two subunits, gyrase A and gyrase B, and two subunits of gyrase A and two subunits of gyrase B, makes it a DNA gyrase holoenzyme, which makes it a functional form. And identifying repositioned drugs which targets DNA gyrase B subunits, which holds a ATPase binding domain. So that provides the energy through ATP hydrolysis for this enzyme to perform catalytic function, which is performed by the other subunit, which is called DNA gyrase subunit A. And inhibiting the DNA gyrase catalytic cycle ultimately perturbs the growth of the Mycobacterium tuberculosis. And so these are the known inhibitors for the gyrase B, which is fluoroquinone compounds, gaticloxacin, moxifloxacin, levofloxacin, and gemifloxacin, and other floxacin analogs. And these are some of the gyrase B inhibitors: diosprin, neodiasprin, and isodiasprin. And as for till now, there are known control or known inhibitor known for DNA gyrase B is novobisin, which is not hydrophilic in nature. Though the hydrophobic active site pocket makes the DNA gyrase ATPase domain as a more challenging to find out the new drugs against this subunit. And these are the basic objectives of my work: to clone, express, purify the full-length DNA gyrase, and identifying the drugs against DNA gyrase, and evaluating the binding affinity and identify drugs using biophysical, biochemical techniques. Finally, evaluating the functional dynamics of the protein DNA, protein ligand intercomplexes, and eventually evaluating the antimicrobial potency or efficacy of the identified compounds. So basically, the topoisomerase are eukaryotic, prokaryotic. In prokaryotic, it has been classified as topo 1, 2, whereas in prokaryotic, it has been classified as topo 1, 2, 3. The one which I have targeted is topoisomerase 2 family DNA gyrase. And this is the overall structural view of the gyrase A and gyrase B subunit. Gyrase A has a 53 kilodalton ATPase domain and top BK domain, and gyrase A has a catalytic core and C-terminal domain. And this is the overall flowchart of my work. Gyrase finding out the drug target and screening of drug bank compounds against the gyrase B active site, and analyzing and finding out the lead compounds, and evaluating biophysically, characterizing the protein ligand complex using biochemical techniques and biophysical techniques. And basically, this drug bank libraries, phytocompound, natural library compounds were screened against the gyrase B subunit. So the focus of the study here is on FDA-approved drugs from a drug bank library. So the top hits obtained, the docking, the virtual screening went on like this, like HTVS docking, SP special precision docking, and the XP docking based on the criteria and ligand parameters. These are the 4 compounds: echinococide, doxorubicin, epirubicin, and idarubicin. These are the 4 compounds which has been selected based on the ADME properties and based on its interaction with the active site residues, and how closely the compounds overlapped with the AMP analog or the co-crystalline structures of gyrase B with ATP analog. And this is the basic, this is the structural cartoon view of DNA gyrase subunit, and the box region indicates the active site. All the compounds are screened against this ATPase domain. And these are the DOC score which was obtained using Schrodinger software. For echinococide, the DOC score obtained is -12, whereas other anthracycline compounds, doxorubicin, epirubicin, idarubicin, for which it was obtained -9.9 kilocal per mole. And the positive control for the gyrase, as I mentioned earlier, novobisin, also has been considered in the docking study, which showed the XP docking score of -8.8 kilocal per mole. And these are the docked complex structural representation for all.
Dr. Bala, let me remind you, you have got only 2 minutes remaining.
Yes, yes. So this is a docked complex for all the 4 compounds. And the MD simulation shows that the complexes are stable. RMSD graph shows that the compounds are stable over 15 nanosecond simulation. And RG shows that there is no perturbation in the protein folding or native form. And the proteins are cloned, purified using conventional cloning and purification strategy, and the GFC purification were performed using supertext column, and CD spectroscopy shows that more than 60% of protein is alpha helix. And the fluorescence spectroscopy study shows that the KD value for KD value among these compounds, we showed echinococide as 4.1 micromolar, which is shows a very good affinity as compared to the other 3 drugs. And further, the compounds were taken for the SPS, surface plasmon resonance spectroscopy, to characterize the protein ligand interaction, and in which again the echinococide shows a 0.65 micromolar KD value as compared to the other drugs, and as compared to novobisin positive control, which showed a 1.5 micromolar. So the biophysical studies conclude that echinococide has more high affinity or higher affinity towards the active site region of the gyrase B. And the thermal denaturation studies again showed that upon binding of echinococide to the active site domain, the complex gained the thermal stability, which is compared with the apoprotein, which is 52.1 degrees Celsius as a TM. And then ATP assay was performed, in which the 1 micromolar of enzyme was taken against the 1 millimolar concentration of ATP.
Sir, it is it is time, sir. Please.
Yes. So the conclusion of the ATP study is echinococci shows 2.1 micromolar as compared to other drugs, which shows higher inhibition as compared to other drugs. And the two subunits were purified, and the DNA superpowering assay was performed, and all the compounds shows the superpowering inhibition. And finally, the compounds were taken to study antibiotic susceptibility against the MTB H31 RV strain, in which echinococci first it was studied with a smegmatic surrogate of MTB, in which echinococci shows 3.6 micromolar, whereas the other compound shows more than 7 micromolar. And it has been tested on MTB H31 RV also, in which epirubicin shows 6 micromolar and echinococci shows 6 micromolar. And this study, this we are continuing in by improving the structural analysis of these compounds. And this
Sir,
yeah.
Sir, please.
Yes, I'm finishing. Yes, I'm finishing. So the conclusion of the study is echinococci, which is a caffeic acid glucoside, which shows a higher binding or inhibition against the protein, and ultimately perturbs the growth of the Mycobacterium tuberculosis, which has been tested on the wild-type strain. And we are in the verge of studying, continuing the study on drug-resistant and extremely drug-resistant strains of MTB H31 RV strain as well. So this work has been communicated in Biochemical Journal. It has been recently accepted. Thank you.
Now the floor is open for question. I would request Professor Padmanabhan to ask if he has any questions.
I would like you to, as you were a bit hurried in the end, I would like you to sum up what is the significance of your work as far as medical applications or biochemical applications are concerned.
Yes, sir. By screening the drug bank libraries, we have found out there are anthracycline analogs and echinococci compound. Echinococci is a caffeic acid glycoside. So these are the compounds which are showing a higher potency against the ATPase domain of gyrase B subunit. So till now there is no hydrophilic drug which has been come up with to target gyrase B ATPase domain. So echinococci is a water-soluble compound, and it complies all the ADME properties. And it is not a FDA approved drug, so still we are working on the analogs of echinococci to make it more potent and to comply the ADME properties. And the toxicity studies are compared with the literature. So the MIC which I have obtained for this echinococci is 12 micromolar, so which is in the marginal range. So it is neglecting the toxicity concentration. And further, the structural analogs, I'm working on synthesizing the structural analogs of echinococci compound. So, which I'm sure that it will enhance it will enhance the potency at a much lower concentration on MTB H31 RV strain.
I have a small query, Dr.
Yes,
Bala.
Yes, sir.
That how do you think that this could be so specific? When you did, you try to dock it into a single molecule. Now, many molecules may have a similar contraptions or similar sites where it can dock.
Yes.
This molecule you are trying to repurpose anyway, right?
Yes.
So,
Yes,
please. I need.
So after performing the docking, we have compared the docked complex with the Koch-like structure complexes actually. So it was the RMSD was less than 1.5 angstrom actually. So it was completely overlapping with the Koch-like structures actually. And I've compared the active site residue which are interacting with the compounds which I've screened with the ATP analog, which is AMP-NP. So the interaction pattern was almost, because due to time lag, I could not able to show the interaction map and show the table. So almost the prominent residues in the active site regions are interacting with the compound which have screened actually.
Okay. Thank you, Dr. Bala. It was a nice presentation.
Yes,
Professor Padmanabhan, can we move ahead?
Yeah.
Now I would like to request Dr. Polapandian, Dr. Rajakanni Polapandian, to share his screen. He is going to speak on synthesis, characterization, and in vitro biological screening of heteroleptic ship-based metal complexes. Over to Dr. Polapandian.
Dr. Polapandian, can you please unmute yourself?
Yes, sir. Yes, I am waiting. So are you visible, sir?
Sir, you have to focus your camera also to your face. That's.
So due to very weak, too much. I'm going to present the title of the work is Synthesis, Characterization and In vitro Biological Screening of Heteroleptic chipase metal complexes. So what is chipases? It is introduced by Chip in 1879, which contains azomethane group in the organic silicon. It is obtained by condensation between carbonyl group and primary amine. The
Dr. Pandian, Dr. Paul Pandian,
Yes,
can you
sir.
focus the camera to your face? I mean, half of your face is only visible. Please. No, just turn. You can adjust your screen angle, laptop screen angle, nothing else. Yeah, that would be good. Bit down, I guess. Yes. So you can again project, put it in a presentation mode. Please continue, sir.
Yes, sir. So the azomethane group play a prominent role in biological application due to excellent heliating capacity. They are stable and they can tune ligation aspect by various density and basicity. 4-amino antipyrin derived chipases are very important because there are a lot of biological applications. It is used as analgesic and anti-inflammatory, antipyretic, but they have it side effect. It's called agranulocytosis. Derivatives of 4-amino antipyrin reduces its toxicity. So on this basis, it is essential to choose 4-amino antipyrin is a starting precursor in this research. So the aim of the work is to synthesize mixed ligand coordination compound, and it will be characterized by spectroscopy and analytical tools. The synthesized compounds are planned to investigate DNA binding studies using electronic absorption titrations. This is our scheme. First, we prepare the chipase compound using 4-amino antipyrin and chinamaldehyde. The chipase ligand is formed, and the chipase ligand react with metal chlorides. Here, Navanagal condensate ligand is it will act as a co-ligand. Finally, we get a mixed ligand chipase complexes. So the physical and analytical data reports that all the complexes different color. Elemental analysis report says that calculated and found values are good agreement with each other, which concluded that stoichiometry of the synthesized compound, the lambda m value is lower, which represents all the complexes are non-electrolytic nature. Then in case of FTIR spectroscopy, the functionality of the free ligand and their coordinating capacity to metal complexes were identified by FTIR spectroscopy. The carbonyl group and azomethane group, stretching frequency vibration of ligand is shifted to lower value in all the complexes. Concluded that coordination is involved between ligand and complexes. There are new bands are appeared, which shows that formation of metal oxygen, metal nitrogen, and metal chlorine bonds. The electronic absorption spectroscopy concluded that the geometry of the complexes, copper, cobalt, nickel have octahedral geometry. Zinc complex does not show any DD transition, so we cannot conclude that the geometry. In case of H1NMR spectrum, we compare ligand and zinc complex system. The azomethane value, the azomethane signal is shifted to downfield. It judges that deshielding of azomethane group due to coordination with the metal ion. There is no appreciable change noticed with the remaining signal of the zinc complex. In case of C13NMR spectroscopy, we compare ligand and zinc complex system. Only azomethane group and carbonyl group signal shifted to lower wavelength indicates these groups are involved in the complexation to metal ions. So finally, mass spectrum, the ligand shows molecular ion peaks 317, which indicates the molecular weight of the ligand, and in copper complex molecular ion peak 665 represents the molecular weight of the copper complex. And the DNA our metal complex interaction is very important. There are two different interactions are possible. One is covalent, another one is non-covalent. In case of covalent interaction, it is a strong, irreversible, and form attack with the nucleotide. But the non-covalent interaction is a very weak, irreversible process. There are so much number of non-covalent interaction, interhalation, group binding, particularly major and minor group binding, insertion, and electrostatic binding. So generally, metal complexes DNA interaction is non-covalent. The type of interaction is investigated by UV absorption titration methods. So in electronic absorption titration method, all the complexes in the presence of Gottheimer's DNA at different concentrations were measured. The interrelation among the metal complexes and the DNA lead to hypochromism and pathochromic shift. This indicates interrelative binding mode due to strong interrelation between metal complexes and base pair of DNA. With the increase of concentration of DNA, the absorption intensity of complexes decreases and lambda max value shift to red region. This occurs binding induces stocking interaction between the planar aromatic chromophoric group of the ligand with the DNA base pair. The figure represents absorption spectra of copper and nickel complexes.
Sorry to interrupt, Dr. Pandyan. I'm sorry to interrupt. Dr. Pandyan, you have left 2 minutes left for your presentation.
Chipases, we prepare chipase mixed ligand complexes and characterized by spectral and analytical tetra. All the complex octahedral geometry, they show poor electrical conductance, which reveals that the electrolytes are the helides are non-electrolyte. DNA binding studies of all the above complexes studied by electronic absorption spectra, which are associated with the interrelating DNA interaction with the different binding studies. Thank you, sir.
Thank you, Professor Pandyan. I would request Professor Padmanabhan if he has any questions.
Please go to the summary and conclusion slide. I mean, you have written ligands afford transition metal complexes.
Yes, sir.
What does it exactly mean?
So afford means the complex contains two different ligand. One is chipase, another one ligand is Navier-Stokes condensate ligand.
Now, what is the significance of these metal complexes?
So in case of mixed ligand complexes, it increases the biological activity of the compounds. As compared to chipases and Navier-Stokes condensate ligand, the biological activity is increased.
Okay, now my last question. Though you have metal complexes here, you are showing poor electrical conductance, and in relation with the dielectric properties, how do you kind of explain this?
Sir, I cannot understand the question.
See, despite having metal complexes, the electrical conductance is very poor, and they are non-electrolyte, basically.
Yes, sir, non-electrolytes.
Have you tried any dielectric studies, and then have you proved that despite having metal complexes, these are all the mechanisms that kind of make it more a dielectric than an electrically conducting?
So our metal complexes is insoluble in some organic solvent and water. So we can use DMSO solvent. So they have some electrical conductivity values. So the data shows some less than 40 or 30 lambda m values.
Okay.
Okay. Thank you. Thank you, sir.
Thank you, Professor Paul Pandyan.
Thank you. Thank you, sir.
You can unshare your screen, and thanks for finishing it before time. I really appreciate. Next, we may have Dr. Dipesh Kumar Kaur is absent. As of yet, he hasn't appeared. So we may call Mr. Krishna Bhatt. He is available.
Mr. Krishna Bhatt, can you please?
He is available.
Yes.
Can you switch on your camera?
Yes, sir. In a moment.
So we have Mr. Krishna Bhatt. He is going to speak on progressive CB recommendation system based on KNN algorithm. It's a neural network he is going to speak, I guess. That's on AI. Over to you, sir, please.
Yes, sir. I can't figure out how to present.
There is a specific icon,
got it.
share screen, green one, yeah.
Got it. Okay. Okay.
We are unable to hear you, sir. Mr. Krishna, Mr. Bhatt, we are unable to hear you.
I think he's having some internet problem.
Okay, so should we ask him to reconnect, something like that, rejoin?
We can see his video got stuck.
Why he is having a Google Meet? So
I have just texted him that we are unable to see you. Let's
let's see. So do we have anybody who has rejoined us, like probably Dr.
so we can.
Vitrivalan?
Vitrivalan is. Can we speak? If I don't see Vitrivalan in the participant list, so unless he has joined with some other name. No, he's not here.
No, we have to be very careful in that one. Suppose if he is not registered, he may send some other student also. On behalf of him, some other will present.
So, sir, can you announce that who is representing Dr. Vitrivalan should come forward and send a private message to Ankur or me?
Yeah, one minute. I tell.
Please announce.
In the session plan, Dr. Ankur is having the session plan, no?
Yes, I do have. Dr. Vitrivalan has been given timings from 6:10 until 6:20, but he has not yet in the meeting.
He came later.
No, he has not yet come. He is not in the meeting still. And the Dr. Dipesh Kumar Thakur is also not here. So Mr. Krishna Bhatt is here, but his video is getting stuck and we cannot hear any message or any.
No. Shall I remove him and then he will join again?
Yeah, please, that would be good.
Okay, we'll please remove him. We'll wait for some time if he will get back to us.
Okay, I'll try. What is his name?
Krishna.
S. Krishna Bhatt. B-H-A-T, Bhatt.
Yes. I'll remove him.
I should stop my timer.
Back to apologize. Judges have to wait for more time.
He's back.
No, I asked him to, I only made it to waiting him. No, I'll send the message. What happens?
Yeah, he's waiting. I just admitted him. He has joined.
Krishna, Mr. Krishna, are you able to hear us?
He left again.
Yeah. Let us see. I think he left.
We can wait.
Yeah. Dr. Ankar?
Yeah, he's again here. I just unmuted him. I have just sent the request to it himself.
No. Dr. Ankar?
Yes.
My mobile is off. No battery charge down. So please, anything you just message in the Zoom itself.
Hello.
Dr. Krishna is already here.
Yeah, Mr. Krishna.
I apologize for the setback. For some reason, my system crashed. So, may I start from the top?
Please.
Okay, sir.
Don't you have a downloaded slide, sir? Don't you have downloaded slides?
I do, but then that seems to be a problem. Whenever I present it in a PDF format, something crashes. Okay, sir. So I'm Krishna Bhatt from Kerala, Federal Institute of Science and Technology. So I'm going to talk about a CV recommender, which is a helper tool for the HR management in most of the companies who are looking to recruit new employees. So let's start with why we need such a tool. The main reason we need such a tool is due to the huge job pool that is now starting to emerge in the world. Also, we need to eliminate human bias. Human bias such as race, gender, ethnicity, nationality, and all can affect the selection of the applicants. So that's also another reason why we need an automating tool so that we can get a fair and square selection of recruits. Another team is that another main reason is the knowledge gap between the HR team and the tech team. Most probably the recruitment will be for the tech team done by the HR team, and due to the knowledge gap, the HR team might recruit participants who are not exactly capable enough to join the HR team. So those are the main reasons. These are some of the relative works from what we found out researching this particular niche of computer science, or rather machine learning, is that very little work has been done, and most of the work has been done for the person who's seeking the job, not for the person who is seeking employees. So the strongest work we've come across is the first one listed here, which is resume matcher, which basically matches your resume to most of the job recruiting websites that are available. Yeah, so let's get to the pre-processing stage. So our system mainly focuses on the pre-processing stage. That it's very important because the resumes come in the format of PDF, and they may have a lot of redundant and irrelevant data that is not concerned with the job offered by the particular company. So the first input that we have is the resume database itself. So we have a set of resumes or CVs. We need only the relevant information, such as the degree, the place of the degree, CGPA, the programming language, IS, like those kind of relevant info, and certain event info, like if he has visited events, presented some papers, stuff like that. So the first thing we do is separate out such stuff. So we separate out directly readable stuff. For example, directly labeled stuff like CGPA 9.8, like that. That's very easy to read. We separated that out with a descriptive format of explanation. So basically, the easier to read part is read then and there itself and stored in a separate file. And 9.8, like two parts of the resume are tokenized and stemmed. And the descriptive part, relevant information, is extracted in the second pass. The data from both these passes are stored in intermediate files for each resume in the database. The second input that we have is from the side of the recruiter, which is the job description. It may consist of a list of skills that is plainly listed, or it may be very descriptive in nature. If it is descriptive in nature, we provide the way to pass, tokenize, and stem them so that we get relevant information from that. After that, each skill is assigned a weight. The reason for assigning a weight is to progressively increase the quality of the suggestion that comes to the person who's looking through the resumes. So all skills will have equal weight in the beginning, because in the beginning we currently don't know the exact taste of the company that's recruiting, right? So and we can only judge after certain number of suggestions are evaluated. So so block diagram. This is a block diagram. This is how our system looks. So we have a set of resumes and job description. The job description has weighted skills. The intermediate files are stored separately, and then TF-IDF is used to assign some. TF-IDF is used to assign to map the resumes as well as the job description onto an n-dimensional space, and then KNN is applied on it. So let's get to the main process. So the first iteration, that is when the program just starts up and finishes parsing all the input. It just first it's mapped onto a n-dimensional space, and the KNN algorithm is applied onto it. With the KNN algorithm applied, we get let's say the k is equal to 10. We get it just having suggestions from the system. So the HR manager, let's say, who's a user, he can check out each suggestion, and he has 3 options that he can do: accept, ignore, or reject. So The resume that is rejected, that's the most important part. Resume that is rejected means there is something really wrong with the resume that the HR manager had to completely ignore it, as in completely reject it, which does not fit the particular job. So that rejected resume is removed from the data set, and then so that it doesn't affect future calculations. Resume that is accepted, which means good news for the applicant. The skills shown by that particular applicant has increased weight. As we know, we weighted skills earlier. So now the skills that are listed here, intersection with those skills will have increased weight. So the whenever the next next 10 sessions come, it will be in favor of these particular skills. The resumes that are ignored may not necessarily be bad resumes. It's just that the user may be looking for better ones. So we slightly decrease the weight of the skills. So only slightly, because of course we don't have to bias the resumes, right? So slightly decrease the weights, and then we calculate the gain and again. So this is a brief glimpse of our system. Yes, sir.
Only 1 minute left. So
okay, sir. Yeah.
Try to finish.
Yeah, it's almost done. Yeah. So this is a brief glimpse of our system. So we have the accept, ignore, and reject stuff. We also have we also have a provision for putting comments, but the current version does not support comments. So this is how the system works. So it progressively gives you better and better suggestions. Thank you.
Thank you, Mr. Krishna. Now I would request Dr. Padmanabhan to ask a few questions you have.
Yeah, it was a very interesting presentation. I would like to know whether you have any strict format for people to put up their CV or resume or biodata or a short biodata.
So that's the thing, sir. There is no.
I'm not finished. In the list,
Okay.
I saw resumes, I saw CVs, then I saw people using biodata. So, like, unless otherwise you have a strict format, I'm afraid that you will not be able to wait and then do the performance properly, or say do the skill set or other kind of evaluations properly. So, I'm sure that you have some kind of a format.
That's the thing, sir. We are trying to avoid those kind of formats because literally there is no agreed upon format in the world, and we can't actually force that upon anybody. So what we are doing is in the current version of the project supports either so the all files should be either a CV or a resume or a biodata. So there can be mixed stuff in it. So that's all we are asking for now. In the future, we may have provisions to remove that problem as well. Yeah.
Like, if you don't have a strict format for biodata and then required skill sets, how will you do this kind of an analysis? So what do you look?
Okay, so yeah, we have dictionaries that are prepared for this kind of stuff. Let's say NLP has been I'm sorry, sir. Kind of tense right now. So a lot of work has been done in NLP by us to ensure that the data is extracted properly. We have dictionaries that look for certain kinds of words which are relevant to the job in particular. In fact, we have also provisions that the job of the person who's offering the job can create his own dictionary or add to our dictionary to increase their quality of suggestions.
Yes, in case somebody is looking for any new skill set or whether they're venturing into something like a new activity, and you would look for new dictionary and all that. So
yes, so they are they don't need to look for new dictionaries. They are welcome to edit our own dictionaries. So they have tech teams who can easily bridge the gap between that.
No, like how do you wait, or say how do you analyze those things when something requires an entirely new skill set, or say whether you're venturing into something new, looking for people with only such skills?
Exactly. This is made for such niche jobs which require very specified skills. So we ignore all other irrelevant stuff. So for example, we may need a person who's very proficient in Blender. Blender is a pretty popular software, but there are very little people who know how to actually use Blender. So in their resume, they may have all kinds of skills such as Unity, Godot, all kinds of game engine stuff. But we are looking only for Blender. So if we don't find Blender there, we are not gonna select that applicant.
All right, thank you.
Thank you, sir.
Thank you so much.
Dr. Devashish, is there any question?
No. Thanks, Mr. Krishna.
Thank you, sir. Thank you.
So over to you, Ankur. Dr. Ankur, over to you now.
Yeah, so this is Bhaskar actually, and the co-host. So with this, we have come to the end of this session, after evening session, and I would like to thank on behalf of the organizers, Professor Jitendra Satija, Professor Devashish Mishra, and Professor Padmanabhan K, for your valuable time and agreeing to be a panel member and helping us to find out judging this all the presentations. So thank you very much for agreeing to be a judge, and thank you very much for your time. Thanks a lot.
Thank you so much.
Thank you,
sir.
Professor.
Thank you so much.
Professor.
Thanks for inviting, sir. Thank you very much, sir.
Thank you. Bye.
I think we'll have to fill the form and then send it as early as possible. What is the
we should send it to Rajan sir only, Professor Rajan.
Yes, sir. You can send it to me. No problem.
Thanks.
You take your own time. Tonight or tomorrow morning also you can send it. No problem.
No issue, sir.
You relax for some time, please. Thank you, sir. Thank you.
Thank you very much.
Yeah.
Thank you, sir.
So Professor Rajan Babu, would you like to give some closing remark for today?
No. The students are present. No. Any oral presentation is pending? Everything is over.
Yeah.
If that is the case, I thank all the judges as well as host and student participants and those who have presented today's evening program. And I hope you can get the result about the selection of best presentation and during the valedictory function. Please join with us on 28th. The valedictory function is on day after tomorrow evening 5 to 5:30. Right, valedictory function. At that time, we will declare the best presentation. Thank you very much. Thank you, one and all.
Thank you so much.
Thank you. Okay, bye.
Thank you.
So, Dr. Ankur, shall I end the session?
Yeah, we can stop the recording and end the session.
Yes.
So Dr. Rees will be tomorrow testing his slides in the.
No problem.
Yes.
I will come by 8:30 tomorrow.
Okay.
Even 8 o'clock also. No problem.
No need. I will be coming at 8:30.
Okay.